All right, guys. So on the screen. All right. So after late starts, we'd expected more persons to be here already. One person said that they have another class. I guess maybe other persons have other classes as well because everybody have exams other than just admits. All right. Um, so Dominic, you sent me some question, but you had a problem with it. Didn't tell me which paper. So you don't have to end and tell me which paper. So let's say we're gonna run this. If anything, I can maybe figure it out. All right. I can maybe send that document to send to myself and pay. Right. Um, so as I said to you guys, this exercise is really gonna be driven by you. So it's a matter of doing what you want to do, going through stuff that you want to do, explaining what you want to get explained again. You get me? Jama, how much paper you have left? How much paper you have? Have 3 papers left. All right. But the same thing. If you have any questions you want me to explain, then let me know. And the easiest way to do it is tell me the past paper that you do. So listen now. The first have some kind of order and structure. I would say we do it by a module. We do it by a module. Question 1 and 2. So we do that question 1 and 2. Things in question 1 and 2 that you want me to explain, we do that for about an hour, 1 hour. That might only need an hour. I don't think there are a lot of things in module 1 that people want to explain. Right? And then we'll go to module 2. Again, in module 2, we'll do maybe an hour, hour and a half of questions from past papers that you want me to explain. It's really about now at this stage, looking at the past papers, if I need to explain something in the theory, I'll do it as best as possible to see what the background is, right? For each thing. And then we'll break again a little bit. So to make a 15 minutes break also in between. And then we'll go on to module 3. And the module 3 maybe for that might be the most time based on what I've seen. Because we might need more help in module 3 than anything else. The integration and the differentiation and so on, in module 3. And then now we can maybe give some time to the statistics probability. Some persons seem to be comfortable with those in a sense. And also the motion and straight line. You know the motion and straight line questions nowadays compared in module 2 with the differentiation integration. The kind of putting it in that now. So we'll clear those first. And then if you have time, we can maybe look back some of the older ones where those questions just come by themselves. So we really want to be focusing on questions that are of the nature and structure that we expect the exam to be, which is a more recent exam question. So we prefer to work on more recent questions down to the older ones. So we really go to the older ones only if absolutely necessary, because you expect the questions to be more like the curve, more like how they set them down, especially the motion and straight line questions, because the time I do it up with the differentiation integration. All right, so we're in module 1, guys. So you sent me a couple questions. So I'm looking and see what if I can figure out which papers they're from. And if you have any in particular, module 1, question 1, question 2, of which exam paper. That's why I said I need you guys to do that to make this preparation, make this activity a little bit quicker. If you know particularly which question you want me to explain. So let me see. The question here you sent me were module 2. All right. Dominic, you had any module 1 in here? No? Huh? Have any paper? All right. So we can do a couple questions on module 1 from those current papers. Right. So I'm going to see if we can find the 2025 paper in this device. So I do have it here. This is 2024. I want to the most recent papers. So I'm look over here if I find the 2025 or look over here. 2025. All right, here we go. This is the Advanced 2025 paper 2. This is the Advanced 2025 paper 2, question 1. All right, so we can do these two questions, question 1 and 2, model 1. And I think you sent me this question, Dominic. I think you sent me this question from 2025. This one. All right. So let's go. 19. Mr. 19. One person online, right? Aaron, online, can you hear answer the screen?
Yes, sir.
All right, cool. Not be as clear, right? Not be as all right. All right, so let's go. Number 1. Let's see if it's the but I don't see if I know. So number 1 gives us this thing to solve. All right? They give us this to solve. I always say to the student, well, what is this really? This is really 3 to the 2x plus 1 equals 21. It's quite simple. When the thing that you're trying to find is in the power, you need to take logs. Take log on both sides to get this out of the power. You can take logs to base 10 on both sides, or because this is actually base 3, in this number, you can take logs to base 3, your choice. It depends on the calculator that they have. Because some calculator you can work in base, whichever base you want. So let's say I'm working in log to base 10. I'm going to take log to base 10 on both sides. Right? So to do that, I'm going to say, all right, I'm logging each side. So I'm going to take the log of this side. No, LG just means log to base 10. Log to base 10. So I'm taking log to base 10 of both sides. This whole numerator comes to the front as a whole multiple. People make sometimes that they put it down like this. They put 2x plus 1 and separate the terms like this. And then they put the log of 3 beside it. And so it now looks like 1 time log of 3, which is wrong. It is the 2x plus 1 is the entire power that is there. So you need to bracket it like that. All right? And that is equal to the log of 21. So the first thing you want to do, you want to transport to make this x a subject. So I take this log of 3 and divide it under here. Let's go step by step. And so 2x plus 1 becomes the log of 21 over the log of 3. Then we can subtract the 1 and divide by the 2. So the x becomes the log of 21 over the log of 3 minus 1 all. So we divide 2 under here, all over 2. That's what the x becomes. Put that in the calculator, work it out, and you have the answer. All right. Wrong thing I press. Wrong thing I press. Let's go again. See what I want. So here we're gonna just put this in the calculator now, exactly as it appears there. So the fraction, on top we have another fraction. It's a log of 21. Log of 21 with my log on this screen with my log. I am not seeing my logs. Or see here, log to base 10 of 21 over log to base 10 of 3. Put a minus 1 beside it. Put that all over 2. And the calculator gives us 0.886. The 3 significant figures. That's it. All right. This one says, determine the value of x and y that satisfies these equations. You're solving them simultaneously. That's what this is, simultaneous equation. Right? So I don't know if I need to do this. It's a simultaneous equation, guys. That's what this is. Right? I mean, I don't see why I need to be teaching simultaneous equation at this stage. So I have y plus 3x equals 2. and I have y plus 4 equals, and this really, if I expand it out, it's 5x minus 2x squared. So I have those two equations to solve symmetry, whichever method I want to use. If I subtract them, I will eliminate the y. Or we could make y the subject of this one and substitute it for the y here. Your choice. It don't really matter. So let's say I subtract them to get rid of the y. Let's say I subtract them. I'm going to subtract. So y minus y, and I'm subtracting them. Let's say I'm subtract. Decide which you want to subtract. Let's say I subtract them this way. This one down here, minus that one up there. So it's y minus y gone. Then it's 4 minus 3x on the left side. 4 minus 3x equals 5x, well, all of this minus 2. 5x minus 2x squared minus this 2. So you end up with a quadratic equation. You have to put it in the standard form and solve it. So when I take this minus 2x squared, bring it over here, becomes positive 2x squared. Take this 5x, bring it over here with this minus 3x, give me negative 8x. Take this negative 2, bring it over here, add it to the 4, I'm going to get 6 equals 0. Divide 2 by 2, I get x squared minus 4x plus 3 equals 0. Factorize this. Get x and 1 and 3. Signs are the same, they are both negative. Get x equals 1 from this factor, x equals 3 from the other factor. We need to find the y value. Right? Now, this equation would tell us that the y is actually 2 minus 3x. So transpose the 3x. So we can find the y values as well. Y equals 2 minus 3x. So in this case, y becomes 2 minus 3 times 1. Y equals negative 1. This case, y becomes 2 minus 3 times 3. So the y here is negative 7. So we can write our solution over here. A solution is 1 point. 1, negative 1. 1, negative 1. And 3, negative 7. 3, negative 7. But I know everybody will know to do that, don't it? We're going to waste the time to question everybody. Right? Go to that. And that's a simultaneous equation. This one, though. So this one, we have to pay attention to this one. Recent times, CSEC been setting these test times, right? But they have the equal and the inequality. It's a rational inequality. And they have the equal and the inequality. Right? Now, this 10 to 1 to give you answers with the equal sign on it. What you have to know is that because this is a fraction, the denominator cannot be 0. So you have to start out that way. The denominator cannot be 0. So you know that the x minus 1 cannot be 0. So the x cannot be 1. So you cannot put the equal sign on the 1 in your solution. Good? All right. So how do we solve this now normally? So we have 3x plus 2 over x minus 1 less than or equal to 0. Now, theoretically, what you do, you multiply both sides by the square of the denominator. Why are you multiplying by the square of the denominator? Because you want to ensure that you multiply by something positive. So the sign does not have to be reversed. All right? So you multiply both sides by the square of the denominator. So show that. So multiply this side by x minus 1 squared. Multiply this side by x minus 1 squared. Then this now over here is to the purple. This x minus 1 cancels one of these. And this side remains 0. So the inequality becomes a product. It becomes x minus 1, becomes like a quadratic, I should say, times 3x plus 2 less than or equal to 0. So this is now your normal quadratic equation or quadratic inequality, already factorized, that you're trying to solve. And you can use a graph method. Some people doing a thing where they're trying a lot of values and wasting time. Just sketch a graph. No, how are you going to sketch a graph? Ensure that is whether it's a smile or a frown. Because if you expand this, you're going to multiply an x by x. You're going to get a positive x squared term. So you know you have a smile graph. So sketching a graph is a sketch method. The graph will be like that, a smile. You put in the x-axis. And you put in the two roots. The root that you will get from this factor and the root that you will get from that factor. Remember, if you know the roots, you automatically know the factor. So one root is 1. I'm going to put the 1 right here, over here. I have put them such that the x values increase that place. I put them in the right place. So we get 2 negative numbers, and we put it so that the larger negative number is on the right side. All right? And then this factor giving us negative 2 over 3. Negative 2 over 3. Now look what I'm going to do now. I'm going to put an open circle on this end. Why am I putting an open circle on that? Because I cannot accept 1. And I'm going to put a shaded circle at this end. Because I can accept this. That's what those mean. You get me? And then now the less than 0 means that I want this part of the graph that is below the x-axis. Put this as a 1, right? This 1, right? Just a better. This is 1. Means that I want that part of the graph that's below the x-axis. See? Less than 0 is a part of the graph that is below the x-axis. That part of the graph that's below the x-axis here is obtained by values in between these two. In between these two values. That should represent the solution. So your x solution has to be between those two values. Less than the 1. Why am I not putting equal? Because we said you can't have equal on it. Less than the 1. Greater than or equal to the minus 2/3. Right? That is basically it. Right, this vector. So the x has to be between these two values. Less than the 1. But greater than or equal to the minus 2/3. So we leave off the equal and the 1, we include the equal and the minus 2/3. That is it. Your solution becomes that. Same thing. Your x is less than 1, greater or equal to minus 2/3. That is the answer. Now look here. If, let's put it over here, sir. If the inequality, let's put it over here, sir, in a box. If the inequality was instead of greater than, right? If it was 3x plus 2 over x minus 1 greater than or equal to 0, then everything stays the same, except now that you want above the axis. You would still go all the way down and still get x minus 1 times 3x plus 2, just that it will now be greater than or equal to 0. You still get a smile graph. You still get a smile graph for this. Get the same two roots. They can't accept 1, but they can't accept the minus 2/3. But the greater than 0 here now would now mean you want this part of the graph up here and this part of the graph up here. Those parts of the graph are obtained by x values to the right of this and to the left of that. To the right of this one and to the left of this one. Right? So your result is going to be that over here, the x is greater than 1. Or union for or. You're going to write the inequality over here now. X is less than or equal to minus 2/3. And why you have to say or? Because you cannot be greater than 1 and less than or equal to minus 2/3 at the same time. It's one or the other. It is either you're greater than 1 or you're less than minus 2/3. So it's two separate ranges, really. This case, you can at the same time be less than 1 and greater than minus 2/3. Again, that's how we can put this continuous interval. That's an interval. But understand that. Good. So basically, that is it. Right? So the inequality was this, that is what we would have to do. So this will be our solution and take this with the solution. You put the word or inside here, they give it a mark same. But just make sure you put two separate inequalities. Some people even just put a comma between them here like this. Huh? Like this. Yeah, but the proper set notation is really union, and you can literally even, in fact, if they say give set notation, this way you have to write. The right solution set, you have to write this. X is such that if the question says solution set, you are expected to write it like this. Huh? If the question says solution set, you have to give them this. The solution set. You have to write that as a solution set. If them say solution set for this one, you have to do this. You have to do this for this one. Them say solution set for this one. Them want solution set. They write X is such that they write for the same thing. Right? Minus 2/3 less than or equal to X less than 1. If them say solution set, just put this in a solution in the set bracket and write X is such that. This is solution set. Right? This question down here now ask us to state how this solution differs from this solution. Now, if they give it this one to solve, you can't include the equal. You get me? If they give this one to solve, you can't include the equal. That is the essential difference. So for this one, X equals 1 is valid. For this one, X equals 1 is not valid. I can say X is not equal to 1. So you can say that up here. So X equals 1 is valid. Down here, so X is not equal to 1. But 1 can be the solution. That is the difference, really. Right? And so we can even write the solution for this one over here. So, okay, solution for this one. Just to give them more information. Just one mark still, I think that's what they're looking for. For this one, you would say that X is less than or equal to 1, greater than or equal to minus 2/3. For this one, the solution is what we have up here. X less than or lower than 1, but greater than or equal to minus 2/3. So what I like about this is that it's your minute knowledge of this thing. Get me? And so if somebody did it this way and put the equal up here, so by them see that question, they're supposed to say, I remember. You get the message? If them see the one, so why the marks this question? That is the reason. One case, one is okay. The other case, one is not okay. All right? That is it. All right. That's question 1 on this paper. Let's go to question 2. I'm gonna say, all right, so we can do this one as well. This is logs, right? So this one on 2025 says two variables, X and Y, are related by this. All right? It says express relationship in this form. Y equals mx plus c, where A, B, and C. In other words, you want to get your indices out of it. So this expression right now, if we were to rewrite it, this expression right now is actually 10 to the y plus 2x. I can add the powers. Put that equals 0, don't it? Put that equals 3, sorry. But that's not. If we're gonna get logs in it and get this out of the power, I don't want the indices. Again, they're gonna take logs on both sides. So what I did here, I changed this into one expression first. Right? I'm gonna log both sides now. See, they're telling us now, they say take logs. I'm gonna log this side is ready to show that I'm logging both sides. I'm logging the left side and I'm logging the right side. All right? So I log the left side again, the whole thing come out in front as a multiple, as a factor, right? As a multiplier. So it becomes y plus 2x again, you have to bracket it. And the log of 10 equals the log of 3. This log of 10 is actually equal to 1, right? This log of 10 is 1. So the left side then becomes y plus 2x equals the log of 3. And it transpose the x, because I want it like this. I want it to look like this. So you're going to write y equals log of 3 minus 2x. Minus 2x. Now, this, if you want it in the form y equals mx plus c, y equals mx plus c. You want it to look like that, y equals mx plus c. So you can see the gradient on the y-axis. I could know still, and this becomes a gradient, don't it? Don't it? If you draw a line of y against x, that becomes a gradient, don't it?
Yes, sir.
And this becomes a y-axis intercept. But this could be turned around, this could be turned around, and be written instead as y equals minus 2x plus the log of 3. So the log of 3 will be a y-axis intercept. If you draw a graph of y versus x, right? And minus 2 would be a gradient. So this one says no. Hence, state the value of the y-axis intercept on a graph of y versus x. So if, oh, sorry, plus c, my mistake. Y equals mx plus c. Y equals mx plus c, I want to write. All right. So this is the y-axis intercept is log of 3, right? The y-intercept c equals log of 3. If they wanted the gradient, then that would be the m equal negative. If they wanted the gradient, but this is what they wanted. So this is the answer for this question. Very good. Very good.
Yes, sir.
Yes, sir.
All right. So down here now, this says determine if the series is arithmetic or geometric. So if it is arithmetic, it has a common difference. If it's geometric, it has a common ratio. Simple as that. And the common difference is when a term divides, subtract its preceding term. Common difference. A term minus its preceding, like the fourth term minus the third term. The fifth term minus the fourth term. That's common difference. Common ratio is a term divided by its preceding term. Like the third term divided by the second term. The fifth term divided by the fourth term. All right? So you just need to see. Now, looking at this, looks like it is geometric. So if it is theta, then you can know. If it is arithmetic, it has a common difference. If it is geometric, it has a common ratio. A common difference is that term minus the preceding term. So here the D is equal to Tn minus the term before. This is Tn minus 1. Down here, the common ratio would be equal to a term Tn divided by the term before it, Tn minus 1. So like the fourth term divided by the third term. So that's what we're testing. So let's look at this stuff. This looks like a common ratio between two us. Right? Everything at 3, multiplied by 3, right? So it's clear for this one that this series can be written as, this is clear, can be written as 2 plus 2 times 3 plus 2 times 3 squared plus 2 times 3 cubed. Don't it? Don't it? Can be written like that.
Yes,
So you see, you keep multiplying by 3. You keep multiplying by 3. Right? And then another one plus 2 times 3 to the 4th power. So that's a common ratio. Or you could have said 6 divided by 2, right? Just so is the same as 18 divided by 6. That's so 18 divided by 6 equals 3. You have done that as well. Common ratio equals that. Right? So you could have done that as well. So whichever way you want to do it, fine. So you could also say, or you could show it by saying R equals 6 divided by 2 is the same as 18 divided by 6, and so on. All of them equal 3, right? Equals 3. So clearly, series in geometry. With common ratio R equals 3. That's it. We got that. Right? Very good.
Yes, sir.
This one now says, in a geometric series, the third term is 25, and the sum of the first and second term is 500. Now let me tell you. AP and GP, most of the time, lead to simultaneous equations. AP and GP, they give you information to create simultaneous equations. If it's an AP you're doing, you solve the simultaneous equation by adding and or subtracting. If it's an AP you have, you solve them by adding, solve by adding or subtracting, solve by adding, subtracting equations. Most times that's how you solve them. Some addition and subtraction. If it's a GP you have, and you form two equations from a GP, you solve by, you normally solve by dividing or substituting. Dividing or substituting. Because you normally get two linear equations when it's a AP. They can add or subtract, eliminate. And you usually get two the equation when linear from the geometry, non-linear. And you solve those by dividing or substituting most times. Substituting. Right? So this one is GP. So look into this. Divide the equation, them are substitute. But these AP GP questions, most of the times, they lead to simultaneous equation that you have to solve to find the unknowns. The A or the R or the N or the G, depending on which one it is. So this one's a GP, right? So we have a GP. These questions are GP. It says, in a GP, the third term is 25. Now remember, the nth term is AR to the n minus 1. So the third term becomes AR squared is 25. And then this says now the first and the second term is 500. And the first and second term is just A plus AR. Simple as that. I'm going to write under here. A plus AR. First term is A, second term is AR. When it's two terms add like that, just add them. If them say the fifth and the sixth term, that's right. If them say the fifth and the sixth term, give you 500, but that's right. AR to the fourth plus AR to the fifth equals 500. Because it's just two terms. If I have three terms, them say add this up, just list them out. Rather than try to put a form. You get me? All right. So this is the first and the second term add to 500. So these add to 500. And so I have two equations that were derived from GP to solve them, I'm going to divide. If I divide, I eliminate the A. Or I could make A the subject of one of them and substitute for the A in the next one. But normally division can work. All right? So normally I divide. So what the question says, tell us that R is greater than 0. Very important. From these two, the R is greater than 0. Don't forget that. So if you get 2 values for R, and you're supposed to get 2 values for R because of that quadratic. So you expect more than 1 value for R. One come out negative, you have to eliminate it. So them say, find the common ratio where R is greater than 0. So we need to eliminate the A. Eliminate the A easier by dividing through. We don't need the A. So we're going to divide them. So we're going to divide them. So to divide them, I can put this side over this side. Either way you want it. I can put this side over this side. Let's say we're dividing this one by this one. Get the square term on top, right? So putting the AR squared on top of the A plus AR on the left side must equal to 25. But the AR squared is 25 over the 500. That's what we're solving. The A's cancel away. The A's cancel gone. You cancel this A, you get 1 right there, so. And this A cancel as well. But understand that. And then you just solve that, cross multiply and solve. But what does this reduce to? It's reduced to this 500 same as 25 times 2. The 50. So same as 5 times 100, which is 5 times 5 times 2, 20. That's all. So it's 25 times 20, right? But anyway, calculator is there. Huh? 1 over 20, right? 1 over 20. So it reduces to 1 over 20. 1 over 20 we get through? We're not telling me, we're not seeing it. Yeah, 1 over 20. So I'm not sure. So this reduces to 1 over 20, right? So it becomes 1 over 20. So I'm going to take the 20 multiply it up here, and then you're going to take this denominator multiply it up here. So know that this is 1 plus R, right? Under here, so left. 1 plus R, left under there. So we're going to end up getting 20R squared equals 1 plus R. What is that? Huh? This is 1 plus R under here, so multiply it up here by the 1. Multiply across by the 1, right? I take the 20 under here, so multiply it up here by the R squared. And you get a quadratic to solve. So you're gonna get 20R squared, want a space. All right, let's write out a smaller. I'm gonna reduce these inside a little column. Let me reduce these. Let me reduce all of this stuff a bit. Let's reduce it a little. And zoom. Right, so I'm gonna get now 20R squared minus R minus 1 equals 0. So this factorizes nicely into 4R, 5R, 1, 1. With a larger product positive, which is smart the one inside here, so make it negative, I mean. So put the 1 here, so, and the plus here, so equals 0. So this now giving me 2 values of R. This factor giving me R equals a quarter. And this factor giving me R equals minus 1 over 5. So remember, this one is not valid, right? This one is not valid. Why is it not valid? But it's R greater than 0. So this is the answer right here. R equals a quarter, the answer. But after that, so this one down here, son. This one says 0 question, no damage. This one says a kitchen, God has an area of this. So the length is this. And so determine the value of A if the width of a garden in meters is this. So this is the width. So it means that this width times this length equals the area that's around it. Length times width equals the area, don't it? Or we could say the area divided by the length is equal to the width. Want it? Your choice. Let's do it both ways. Let's do the second way that I just said. The width, we all know that length times width equals area, right? So if we want to find the width that has the A in it, the width will be the area over the length. So the width in this case is A plus root 5. It is equal to the area of 10 minus 3 root 5 over the length of 5 minus 2 root 5. Just to get what the A is, I need to get this to look like that, which is to rationalize this denominator. Get me? If I rationalize this denominator, get this whole expression to look like how that one look, and then I will see what the A is. I want to write this whole thing in terms of some number times root 5 plus root 5. So I need to rationalize the denominator. Get this sum under here. It's a rationalize the denominator question that he hide in one thing there. Remember, I said you have to learn to rationalize the denominator of surge. And this is then finding a way to put a real life situation. To an occasion, we have to rationalize it. I have to do operations with surge, multiply surge and so on. So again, I'm going to show this question another way. We have to multiply these two things and equate it to that to set up an equation that we're solving. I'm doing it this way first. I'm going to rationalize the denominator by multiplying by the conjugate of the denominator. So multiply the denominator by 5 plus 2 root 5. Multiply the numerator by the same thing, 5 plus 2 root 5. We work out this, we can see what the A is easily. Let's work it out. So the A plus root 5 is the same as multiply this numerator by this numerator already. So it becomes 10 times 5 first is 50, right? Then 10 times mine plus root 5 is 20 root 5. Then minus 3 root 5 times 5 is minus 15 root 5. Careful now. Minus 3 root 5 times 2 root 5. 3 times 2 is 6. And the root 5 times root 5 is 5. But I said that. Let's put it in parts. Becomes minus 6 times 5. Let's write it out like that. But that's not that. And dividing that now, the denominator now is just the difference of 2 squares, don't it? So it becomes this squared, which is 5 squared, minus this squared, which is 2 root 5 squared. I'm going step by step. I could have root 4 times 5 right here, so 1 time. You get me? That's what we have. Let's consolidate the values. So the A plus root 5 becomes equal to, let's consolidate the like terms. Now this right here says 30, don't it? So 50 minus 30 is 20, don't it? So we get 20. Then this is 20 root 5 minus 15 root 5, that is 5 root 5. 5 root 5. Divided. Now this is 25, and this is 4 times 5, don't it? Where square this is 4 times 5, which is 20, don't it? So it's 25 minus 20, so I know it becomes a 5. Again, when you divide each of these values by the 5, it becomes 4 plus root 5. So if A plus root 5 equals 4 plus root 5, then A equals 4. And subtract root 5. So A equals 4. See that? Let's do the other way if we are multiplying them. So I'm going to make this smaller. Let me shift this up. Shift this up here. And say, okay, if we use the area approach, let's zoom out down here. So we use the area approach, right? Let's do it down. I'm going to zoom it up and say we long time with is that equals area. So what do we know? Let's do it in a different color. The length is equal to What is the length again? The length is 5 minus 2 root 5. And the width is what we're doing. A plus root 5. And the area, and multiply those two, is 10 minus 3 root 5. So another way we could do this question is to say the length times the width equals the area. So I've done it that way as well. So I'm going to put all of this together now and set up an equation with that. The length times the width. So this times this equals that one there. So we could have said 5 minus 2 root 5 times the width, A plus root 5, is equal to the area, 10 minus 3 root 5. You have done that as well. So the length times the width equals the area. Set up that. Now we have to do it. Simplify down this to make it look like that. See that? Take this and simplify it down to make it look like that. Come on, so we can compare the values. All right, so let's expand out this side now. So this side will be 5 times A first is 5A. 5 times root 5 is 5 root 5. Then minus 2 root 5 times A gives you minus 2A root 5. And minus 2 root 5 times root 5. The 5 times root 5 times root 5 is 5. The 2 times 5 is 10, right? That will be minus 10. And that's all equal to 10 minus 3 root 5. That's it? Yes, I'm going to do this time this first to get that. Then I'm going to do this time this to get that. Then I'm going to do this time this to get this one. Then I'm going to do this time this to get that one. All right? So let's put it in a non-search part and a search part. The expression that a non-search part and a search part, and I will call a rational part and an irrational part. This is the rational part. This is the rational part. That's the irrational part. All right. So we're gonna take this now and make it into a rational and an irrational. So the rational is gonna become this and this. 5 minus 10. See that? 5 minus 10. So it's 5A minus 10. Sorry. 5A minus 10 is the rational part. Then the irrational part, now you write that in terms of root 5. So it becomes plus the 5 minus 2A times root 5. That's all equal to 10 minus 3 root 5. So I have two options. You can equate the rational parts. This equal this. And solve for the A. Or you can equate the irrational part. This equal this negative 3. And solve for the A. So we can say either 5A minus 10 equals 10, which means that 5A equals 20, which means that A equals 4. Or we could equate the irrational parts, this part and this part, so that must equal. So we could say instead 5 minus 2A equals negative 3. Throw over the 3 over here, so and get 8 and get 2A over this and get 2A. So you get 2A over the side that equals 8. So again, I get in A equals 4. So I give you either way, whichever way you prefer to do. The end of the day, you set up an equation for here. Huh? Yeah, well, whichever way you do it. Exam. See that whichever way you sit to approach it, the answer can come. You're about it, sir. All right, so that is 2025, question 1 and 2. All right, that's module 1. When we look at 2024, when I have a particular question, what I'm going to do, I want 2024. On 2024. All right. Let's look at 2024. That's a module 2. That's a module 2. Yeah, but we just want to do the modules. We just want to do a period of module 1 first. And then we do module 2. 2024. Admas 2024. That paper is not clean, right? That's not a clean paper that I see it here. All right, so let's do these questions again. Do I need to do this one? First one. Remember, don't put something in the beginning. The following one I'm going to do that. Let me say, determine the linear factors of that. That's the factor. So you're going to divide it. And then you're going to get the positive on the top, the factor of the positive on the top. That's it, right? Good. So and simplified. What will happen? That when you get the factors of this up here, when you get the factors of this up here, you put those factors on top here. So, and you're going to factorize this again into x minus 2 times x plus 2. And cancel it down, right? Work out itself. So some can skip over this, right? For efficiency purposes. Huh? What about this one? Do this one? It's good too? All right. And them say, give me that this equals 6 to 1. No good again. But this expression here is just alpha plus beta squared minus 2 alpha beta. That's equal to the 6 to 1 over 4. All right? That's what that is. All right. And I've got these in terms of the key. All right. I've got those in terms of the key. So no good with this, right? When I write this, I'm sure. I know I'm going to do it. I'm going to do it. They're not that long for it. I'm going to do it. All right. So the alpha beta is minus b over a as you know. What is the a? The a is the coefficient of the x squared, The b is the coefficient, so the b equals a equals k in this case. B is the coefficient of the x, so the b equals 1. The b equals 1. Well, the problem with this question, guys, is that I put a 10 over here. So it's supposed to be a 0. I think it's actually a mistake. This question is meant to be a 0. Because I think I remember this question. If I try to report the k, remember says the k is a whole number. If I try to report the k, not going to get a whole number if you leave the 10. So this is not C. It is a constant over here. It has to be 0 over there. So if we do it as is now, you now get a whole number for the k. If you care over the 10, I make it become make it 25. So that type of the make on the question. So let me just do it. And show you. Because the right way to do it with what they put on the paper is with this other 10. So you need to transpose it and get 0. But the A, B, and C is based on the 0 being here. So this basically would have become kx squared plus x minus 25 equals 0. Then the A will be k, the B will be 1, and the C will be negative 25. So the alpha plus beta, which is minus B over A, would be minus 1 over k. And the alpha beta, which is C over A, would be negative 25 over k. All right? That if you use their figures. But when we find the k for the answer, it's not going to be a whole number. Remember it. Because this actually was supposed to be 0 on the paper. The type, they intended that to be 0. Right? But let me continue working. So those are the things. Then now they tell us this thing, right? As I said. They tell us that alpha squared plus beta squared is equal to this. But remember, alpha squared plus beta squared is equal to that. Alpha plus beta r squared minus 2 alpha beta. So that is equal to 61 over 4. So putting these two things now into this equation and put that equals 61/4. So we would end up getting the alpha plus beta becomes this, which is minus 1/k squared minus 2 times this one, minus 2 times negative 25/k. That equals 61/4. And we're supposed to solve this for k now. So this first will become 1/k squared minus, it's going with a plus, right? Plus 50/k equals 61/4. We don't want it like, so we multiply it by a k squared and also multiply it by a 4 to get rid of the fractions. So I say multiply it by a 4k squared to get rid of all these fractions. So multiply it by a 4k squared. This becomes 4k. No, this becomes 4. This becomes 4. Multiplied by a 4k squared. 4 times the 5, it's 50 is 200. 200k. So you get plus 200k equals multiply this by 4k squared. The 4 is cancelled and you get 61k squared. So bring these two over here, it becomes 61k squared minus 200k minus 4 equals 0. If you solve this for k, you can't factor it. Huh? It's the quadratic formula. Huh? What you get the answer, but what can answer you get? Problem is the question say, let me tell you not paying attention. K is supposed to be a whole number. So those answers that you get don't correspond with the way the question is saying. That's a double meaning a whole number. So you're gonna get answers. Just that they're not gonna be whole numbers. And if you're in an exam room and you expect to get whole numbers, you're not getting whole number. You might waste time trying to search for whole numbers. Because I remember the first time I did this paper and I didn't get whole number, I said to myself, what me so? I mean I search and myself, oh wait, I say, what if this tells me it's supposed to be a 0? I'm gonna do it over with a 0. And I got whole numbers there. You get me? That's what happened. So imagine an exam and you're looking to get whole number because you see this clearly say double K is a whole number. See the where K is a whole number. That's what that means. So you're gonna get answers if you solve it. You get answers. I'm not saying not get answers. You're gonna get answers. Just that they're not whole numbers. So you're gonna get K equals minus B, which is 200, plus or minus the square root of 200 squared minus 4 times 61 times negative 4 all over 2 times 61. And you solve that for the K, right? And you get 2 by this, they're not going to be whole number. But you would do the same thing that I just did if this was a 0, right? If this was a 0, all that would happen here is that the C will be negative 15 instead. That's all. That's all that would happen. The C will be negative 15 instead, and you follow the same. So let me know about a waste of time. Let's leave it at that. I never really tend to do question anyway. So you solve this for K afterwards. Don't listen now. It says for the quadratic equation, we don't honor this one though. For the quadratic equation, determine the exact maximum value, maximum point, and the range using the method of compute. So I want us to compute the square of this. I'm going to do this one time. So to complete the square, we can use the method approach rather than the formula approach. All right, so we have g of x equals minus 5x squared minus 4x plus 2. Now, careful guys. When the coefficient of x squared is negative, I'm going to factorize it. You have to remember to change the sign on this one. Right? You have to remember that. Right? So we'll factor out the minus 5. It's going to get the x squared. We divide minus 5 out that, it's going to get a plus 4 or 5x all into that plus 2. You complete the square of these two terms now. You get minus 5 into x and half of this becomes 2 over 5. All squared subtract the square of this, which is 4 over 25, all inside that, and add back 2. What did we do? We put half of this value here, or subtract the square of this value there. That is our compute this step. That's those 2 steps after you factorize. All right? They expand and everything else remain normal. Normal process going forward. So it's minus 5 times this gives a minus 5 into the x plus 2 over 5 all squared. The minus 5 times minus that. The minus give you a plus. The 25 cancel into this 5 times, and so we get 4 over 5 plus this 2. Well, that 2 is the same as 10 over 5, don't it? So this 2 is where this 10 over 5 came from. They have the same denominator. And so that becomes 14 over 5. So it becomes minus 5 into x plus over 5 squared plus 14 over 5. So what happened now is that the maximum value is this when this inside it equals 0. Right? So g of x max is equal to 14 over 5, the constant value. When is it max? When the x plus 2 over 5 in the bracket becomes 0. That's when the x equals negative 2 over 5. And so that maximum point that I asked us for is this x value, this y value. Minus 2 over 5, 14 over 5. Don't put 2 over 5 as it is actually negative 2 over 5. But it is the value that this is. So the g of x becomes this when this becomes equal to 0. It becomes equal to 0 when this x value is a negative of this y. Very important. That's the maximum point. They're asking for the maximum point, right? And they also want the range. It says determine the exact maximum value or the exact maximum point. So this is the maximum point. I have to give them this. And the range they want the range now. So the range now is because this is the maximum value. It means that the y values will be less than or equal to this maximum value. So the range becomes this. G of x less than or equal to that maximum value. That is the range. So this is the maximum point. This is the range. If it is a minimum, it will be greater. G of x will be greater than that minimum value. Greater than or equal to that minimum. Right? If it was a smile going situation. That minimum. Right? That's question 1. Question 2 now, logs. So they express this as a single. They want everything to belong to base 3. Now watch this now. When you have a number, right? And you want to convert it to a log to a particular base. All you have to do is multiply by the log of that number to the same base. That's all you have to do. All right? So that 2 to turn into a log to base 3. Want to multiply by log of 3 to base 3. Let's go. So let's go step by step. Turn this into a single term. For this one, I'm going to take this 2 and bring it up here on the power. So I'm going to get log to base 3 of x squared. That's what this one becomes. That becomes that. Then this 2, I'm going to turn it into a log by multiplying it, put a part in rate, by log to base 3 of 3. Why? Because log to base 3 of 3 is 1. So like I've multiplied the 2 by a 1. So this is actually equal to 1. But I'm turning it into log by multiplying by log to base 3 of 3. Then what will happen is that this 2 will come up here on the power. I put that in the next line. This one stays as it is. So it's minus log to base 3 of y. Take this 2 and bring it up here, son. So I get log to base 3 of x squared plus log to base 3 of 3 squared, I left out the y, minus log to base 3 of y. So far so good. Know that I have everything. I know that the plus means that I multiply and the minus means that I divide. So I'm going to get log to base 3 of the product of these two, which is 9x squared, don't it? So this is 9 times x squared. 9x squared over y. That's my singular. This is my answer right here. Very good. So the important part of this system is how we get this into a number log base 3 of 3. Just multiply by log of 3 to base 3 and then put it up on the 4 there. So any number you have you want to convert to any log in the base, just multiply by the log of the number to that base. Understand? So you have to do, and then move that number up on top. That's all that. Turn it into logs. Alright? That thing in the red is a key step. This question. You can know, sir, by using logs, express this relationship into a linear form. See, linear form, you want to get it looking like y equals mx plus c. And these are your two variables. All right? So you have to take logs of both sides. All right. So what I would do in this question, I would want to take this 7 and bring it under here. So that I leave the right side with just one expression. And index and index. Right? That's what I would do. So I'm going to write b over 7 equals 5 to the power 3. I don't have to, but can do that. I'll do it. Because if I take log of this side, I'm going to say log of problem, if I split this out anyway. So I could leave it as it is, no matter. Let's leave it as it is. Just take log of both sides. So this, I'm going to take log of both sides. The same way. But I just did, I don't have to. That is a must. Let me make the change on this. So for this expression, I'm going to take the log of both sides first. So I'm going to get the log of v equals the log of 7 times 5 to the t. Remember, the log of a product means that you can open it up as a log of the sum of two logs, right? Log of a product can be opened up as a log of sum of the logs, right? So we'll get the log of v equals the log of 7 plus the log of 5 to the t. And this t can come to the front. So it becomes the log of v equals, let's put this one in front here, so as the first term, so it becomes t times the log of 5 plus the log of 7. Why did I do that? Because my like when my variable term come first in the linear form. And to actually make it look like this fully now, we want the variable to come second in the expression. So I'm going to write it like this. The log of v equals the log of 5 bracket times t plus the log of 7. So now, this is my y over here. So if I compare to this, y is that. Y is my log of v. My m is that. My m is the log of 5. My x is this t right here. So the x is actually my t. So I'm comparing this one, right? And my c is a log of 7. My c is a log of 7. So I need to plot a graph of log v against t. Log v against t. This is going to be my gradient. This is going to be my c. If I plot log v against t, it's a straight line. with the gradient is the log of 5. My C y-axis intercept or log V axis intercept is a log of 7. What do I go to that? All right. It says, hence, take the value of the gradient of a line of a relationship. Gradient of a line. So the line would be the log of V versus T. So the gradient is this one, right? Right? So log of V versus T reduces line with gradient. M equals the log of 5. That's the answer. And log V axis. Now, y axis is the log V axis. Intercept. Of C equals log of 7. This is the answer that I asked for. This is what I want. But I'm just putting this in there as additional information in case I want. So this right here is the answer that I want for this question. I'm just giving you this in case they ask for the log V axis intercept. It will be the log of 7. Just for additional information. But the log of 5 is the answer that I want for this question. Remember, it is the log of V versus T graph that's producing a line. That produces a straight line. Produces a straight line. We put the word straight line on this. Produces a straight line. All right? Produces a straight line. The gradient of M equal to log of 5 and log V axis intercept. So the y axis is the log V axis intercept equals log of 7. Then we have this. So rationalize the denominator. Oh, this one easy. It's multiply numerator and denominator by the conjugate of the denominator, right? So multiply the numerator and denominator by the conjugate of this. So it's 3 plus. Since it's a minus, you want to multiply with a plus. So it's sort of the difference of 2 squares. Multiply numerator by the same thing. So then it becomes equal to multiplying the numerators now ready. So it's 1 times 3 first is 3. 1 times root 2 is root 2. Then root 2 times 3 is 3 root 2. Then root 2 times root 2 is root 2 squared. I could always write 2. That was writing it step by step. But the denominator becomes the difference of 2 squares. This time, this is the difference of 2 squares. So become this term squared, which is 3 squared, minus this root 2 squared. So then it becomes consolidate now. Well, this works out to be at 2, right? Root 2 squared is at 2. 2 and 3 is 5. Then root 2 plus 3 root 2 becomes 4 root 2. 4 then. 4 root 2. 4 root 2. Over. This is 9 minus 2. But this becomes at 2, you know. This is 9. 9 minus 2 is about 7, don't it? 9 minus 2 is 7. That is it. You rationalize the denominator. That's the answer. That's it. The denominator is not a rational number. 9 minus 7. 9 minus 2 is 7. All right? That's it. Got this question now. Let me get this. That's why the sum to 4 values. So if you want to sum to 4 values, you can literally just list them out. You know, formula method, just list them out. That's just 4 values. So see there from that. Then you sum to 3 values, 4 values, 5 values. Just list them out. In fact, it's going to be 5 values. It's going to be start at 0. So 0, 1, 2, 3, and 4. So you just add in the values. See here, just add them. So this becomes We can call it S1, S0, sorry, S0 plus S1 plus S2. Let's not call it some value 1, value 2, value 3, value 4. So let's call it value 1 plus value 2. No, you know, start at 1, start at 0. My mistake. Start at 0, guys, when I equals 0. So value 0 plus value 1 plus value 2 plus value 3 plus value 4. Let's put those values. So the values now is when the R equals 0 first in here. So this is 0. So this value is 5 to the negative 2. If you want to put 0 minus 2 to show it. Plus, this is 5 to the 1 minus 2. Plus, this is 5 to the 2 minus 2. Plus, this is 5 to the 3 minus 2. Plus, this is 5 to the 4 minus 2. What understand that? System out like that. This becomes 5 to the minus 2 plus 5 to the minus 1 plus 5 to the 0 plus 5 to the 1 plus 5 squared. Put all that in the calculator and get the answer. Good to go. Let's put them in the calculator and get the answer. How much I get? 31.24. So I get. So get 5 to the minus 2 first. Plus 5 to the minus 1. Plus, well, 5 to the 0 is 1, right? Plus 5 to the 1 is 5. Plus 5 squared is 25. That's 31.24, the exact answer. That's it. 200 more difficult than that. Let's work it straight. Right? Could set up like a series, like a GP series. I realize that that GP with a common ratio of 5. You multiply by 5. And the first term is 1 over 5. And then you sum to the fourth term. But this one starts with t equals 1. That's a problem. Wait, well, this would be a first term. And the common ratio would be 5. Keep multiplying by 5. So if we become a GP with a first term of 5 to the minus 2. How many terms are there? 1, 2, 3, 4, 5. And n equals 5. Because it starts at I equals 0. But to avoid that, because there's only 5 values, you can just list them out and work them out easily. Get me? Because like some to 20 values now, then you want a formula method. Right? But if you realize that because it starts at 0, when it's at 4, it means that you have 5 terms. N equals 5. See it? Because it starts at 0. Start at I equals 0. Alright, so that's the only thing with it. It says determine whether this series is divergent or convergent. Now remember, only a GP can be convergent, right? Know that, right? Only a GP can be convergent. And a GP is convergent when the common ratio is a positive or negative fractional value. Right? So this one can be convergent. Only a GP. Only a GP where the R is less than 1 or greater than negative 1. Meaning the R is some, if the decimal R is 0 point so, positive or negative 0 point so. Right? That's the only way it can be a GP. If it's not convergent, then it's divergent. So once you don't have this, it means it's divergent, whether it's an AP or a GP. All APs are divergent. All APs are divergent. But some GPs are divergent and some are convergent. Convergent ones satisfy this condition. So only a GP that has this can be convergent. All other series are divergent. So if it is not convergent, then it's divergent. So to decipher this, all we need to do is see if this is convergent. All right? So you want it to be a GP, a common ratio that is a fraction. So the first term right that's what be divided by that will be the R first, negative 2/3. And you want to see if it's the same pattern here, negative 2/3 multiplied here, which it is. Right? So see here, this divided by this tells us that the R is minus 2/3. This divided by this is the same thing, don't it? This divided by that is the same thing. And this divided by this is the same thing. So in all cases, you have a common ratio of minus 2/3, which satisfies this condition up here. Right? Satisfy that condition. See that? Satisfy this condition for convergent series. See that? So you can draw the conclusion. So therefore, it is convergent. Therefore, sequence is convergent. Sequence is convergent. It's convergent. And why is this a sequence and not a series? Why is this called a sequence and not a series? A sequence is just a list of values, and it can be arithmetic or geometric. A series is when you add the values. So if I had pluses in between here, you were adding them, then you would have a series. So let me tell you the difference now. A convergent series, the sum add to a sum to infinity. A convergent sequence, the values tend towards a particular value. You understand? The values, the individual terms trending towards a particular term. In this case, they will be trending towards 0. I say you keep multiplying by this. So the terms are getting smaller and smaller and smaller. Get me? So the terms, the more terms you go, the more it tends towards 0. So you swing between the positive and negative side, it's tending towards 0 anyway. That's this sequence. So a convergent sequence, you're looking at the terms themselves. You're not adding them, the terms tends towards a particular final value. And in this case, that particular final value is 0. They're trending towards 0. The sum would trend towards a sum to infinity. And the sum to infinity is A over 1 minus R. Series tend to a sum to infinity over 1 minus R. But this was not a series, it was a sequence. So the values, the terms, tend towards 0. Terms in this sequence tend towards 0, this example. Terms are getting smaller and smaller and smaller. So know the difference. Because I can answer those things, you know. That's the difference between a sequence and a series. Series means that you're actually adding up the values in the sequence. Sequence is just a list of values. You're not necessarily adding them. See, you have a comma between them. See? You're not adding them. If you're actually adding them, then you would have a series. And a series has a sum to infinity because you're adding them. Right? Series is when you add the values. Sequence is just a list of values. That is a geometric, of a geometric relationship or an arithmetic relationship. That finishes that number 2. All right, so how long we are working on? We're up for it. We've gone towards already. We have to start late. So I'm going to jump on for model 2 now, guys. So I jump on for model 2. We're for model 2 a little bit. And then we can take a break. Take a little short break. All right, so you are giving me, you wanted the number cheese, you wanted the number cheese and these papers. You want 2025. So we'll go back to the 25 paper that we're on. If we go back to the 2025 paper that we're on. Here's this one we're on. Right. And you want number 4, not 3, you want 4. You want this 4. This 4. Dominic, I don't remember. You have to look and see which part of the paper you want. Right? All right. So I can do a check back. Take a break and check back. Remember, make sure I cover all the questions that you want. You all right, Jude? Can I leave? Say, better come for if I leave. You want to play all right, cool. All right, let's go. So this question says we have to differentiate this thing, right? Which part of this will give a problem? To differentiate this. Huh? A 3 you want? Question 3? Okay. This question 3. I said on the grid, draw sine 2x and cos 2x. All right, let me give you a little background with the sine graph and cos graph. And that's why I told you to do the multiple choice paper, because these things are brought out glaringly on the multiple choice paper. Right? Give you a little background on the sine graph and cos graph. And when you see 2x here, so what's the difference? Eh? Pay attention now. So the sine graph was giving a little background on the sine graph and the cos graph. So the pass through, they go up to 2 pi, right? So the 4 main points are pi by 2, pi, 3 pi by 2, and 2 pi. Or we can say 90 degrees, 180 degrees, 270 degrees, and 360 degrees. So it's like you're talking about these 4 places on these places on the quadrant. Here, 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 and here. Right? So right that's at 0, correspond to this. So right that's so up so. Right that's so over so. Right that's so down so. And then 0 and 2 pi the same place. It's a 2 pi again. Right? In a quadrant diagram. So it's like you cover those 4 spaces. So sine graph and the cos graph, both of them go up to 1 and come down to -1. If they oscillate between 1 and -1. Sine graph and cos graph. The sine graph, it passes through 0. So it starts at 0. It goes up to 1 at pi by 2, comes down, come back to 0, and pi by at pi, go down to -1 at 3 pi by 2, and then go back up to 0. So you go like this. That's a sine graph. Right? Sine graph. That's sine 1x, sine x. Sine x. What is sine 2x? Sine x have 1 full cycle between 0 and 2 pi. So sine 2x must have 2 full cycles between 0 and 2 pi. That's sine 2x. Sine 3x must have 3 full cycles between 0 and 2 pi. Sine 4x have 4 full cycles between 0 and 2 pi. Sine half x has half of the cycle between 0 and 2 pi. It's simple, guys. Sine 1x is what they're looking at. 1 full cycle between 0 and 2 pi. So if I'm drawing sine 2x, it means that I need to fit 2 of these between 0 and 2 pi. So I need to fit 1 of them between here, so, and another one there, so. So it's almost like I'm going to take the graph here, I'm going to shrink it, So, sorry. I take the graph here and shrink it like this. And fit one item there. So that's sine 2x. We put another one here, so I double it. So I must fit two of them. I have to fit two of them. Copy, paste. So I now have two of them up to 0 and 2 pi. What you're looking at now is sine 2x. And there are two of them there. This now is sine 2x. Combined there now is sine of 2x. So sine x was when we were one of them. Sine 2x is now when you have two full cycles between 0 and 2 pi. See the difference? See the difference? So that is sine x. That is sine x. One full cycle between 0 and 2 pi. That is sine 2x. Two full cycles between 0 and 2 pi. Sine 3x, I would need three full cycles between 0 and 2 pi. Sine 4x, I would need four full cycles between 0 and 2 pi. So see there? Sine x is one full cycle. Sine 1x is one cycle, one sine cycle between 0 and 2 pi. Sine 2x, I need two full cycles. So if I'm going to have two full cycles between 0 and 2 pi, it means that I know we'll have a full cycle between 0 and pi. See? This is no sine 2x. You know? That's sine 2x. So if I look at it then, it means that I have one full cycle between 0 and pi. That's sine 2x. So when I have sine 2x, I have one full cycle between 0 and pi. Because I have two full cycles between 0 and 2 pi. Because what you're looking at on the screen is sine of 2x. Two full cycles between 0 and 2 pi. So up to pi. No, I didn't want it there. So up to pi is one full cycle of a sine graph. See? See that? So that's why you have to draw a sine of 2x right there. So. See? The same thing with the cost. Let's do for cost now. Let me leave that and do for cost. That's a sine of 2x. Now if I were to do cost, I'll copy this down and the cost on the same page. What's the relationship now between sine and cost? The relationship between sine and cost is a phase shift. Let me take this off and extend this back out and show you. That's my sin x, right? I've drawn back my sin x down here. So. Draw cos x. Cos x starts up at 1, right? So like this shift come over there. So. Actually, this is supposed to pass through by 2 there. So. Right, that's how sin x is. Cos x, I mean. And then I'm going to draw it. But that's how it is basically. So you go like so. That's how cos x looks. That's cos x. So cos x starts up at 1 and go like that. That's 1 cos x. That's a cos x graph. Changes a cos x down. So no, it's a cos x. So it's a sine 2x. Yeah, now. So looking at the screen down is at a cos x. So you think cos x 2 is gonna be? Cos 2x now means you need two of those between 0 and 2 pi. So that I would have to take this and shrink it down like this. And copy it. and paste another one in, like so. So that now combined with the cos 2x. Two cos graph between 0 and 2 pi instead of 1. So one here, so another one here, so. Two cos graph between 0 and 2 pi is cos 2x. Understand that? Now the beauty about this too, they put it on graph paper, so you instead of sketching. Because on graph paper, you really want to plot the points. Get it? Put plot the points and get it. Because you give your coordinates, you give your values. Alright? So you wanted to draw sine 2x, cos 2x, right? So you need a full sine graph up to pi and a full cos graph up to pi. Because they gave you points, you could have actually put them in the calculator and plot the values. Look now. So if you have my calculator in the exam room, right? I put on sine 2 times. I put the angle left now. So 2 times 0 first. 0. I do the sine one. So that pass through 0. I want pi by 2. I put pi by 2 the same. Pi by 4, sorry, pi by 4. Yeah, this is a little bit deeper. I'm showing you what I would do in the exam room, and if I were you, more enjoy this accurate. So I put pi by 4 the same. Right? So I put pi over 4. Fraction pi over 4. I get 0 0.2, 0 0.27. Let's put pi by 2. I put 2 pi by. I get 0. Hold on. Oh, the calculator is in degrees. My mistake. The calculator is in degrees. I need it in radians. So that's the problem. I need it in radians. Change the calculator to radians and go again. Right. So I get 1. Calculator to be in radians. This is the radians. These are in radians. So I make the calculator in radians. So ready again. The pi by 4 give me 1, right? So I put a point up as so. We put pi by 2 into the calculator. You can see calculator? So more for that valuation now. I keep the value in the calculator. Erase and put 2 there. I get 0. So I say pass through yes. I want 3 pi by 2. I change this to 3 pi by 4. 3 pi by 4 I mean. Change this to 3 pi by 4. And the calculator 3 pi by 4. I get negative 1 down and so see there? And then I change that to just a pi. Change this to just a pi. I can put 1. You can put 4 over 4 if I want. Same thing. You get back 0. You draw the graph to do this, so you have a sine graph. See that? So you could plot the points like that quickly. So just do like this now for your sine graph. Like really. That's my sine graph. One to the cross, let's do the cross in a different color. Let's do the cross in purple. So go back to the calculator. Again, I'm on the cos 2x in the exam room. Oh, Lord, let's go again. I'm in the exam room. I want to do for cos. Let us write cos 2 times. I'm going to put 0 first. That's 1. So cos of 0 is 1. Mark up here for 1. I'm in the exam room. I don't know these things. I have a calculator in front of me. I'm going to mark this off for 1. Cos of 0 is 1. Then we need for pi by 4. So I put 2 times pi by 4 now. 2 times pi over 4 in the exam room. I get 0. So I put a mark there and stuff is 0. Then we put in pi by 2. See there? Pi by 2. 2 times pi by 2. I get negative 1. Mark down and so negative 1. Then we need 3 pi by 4. So I come to now boom. I put 3 pi by 4 in the calculator. So yeah. 3 pi by 4 3 pi by 4. Get 0 right here, so. And then I put in pi. Same as 4 pi by 4. I just go back and put pi. I need just pi. Pi. 2 pi. Get 1 up here, so. So I draw my graph through the purple one, then I know say it's a phase shift of this graph. I know that the ratio between sine and cos is a phase shift of this graph that I have on the screen. But we can draw it till it, right? I draw it in purple straight. Go down so turn on this so lift off the 1, put back the 1. Then put back the 1. I didn't put it there. I didn't put it there. 1 up here. So. Alright, so I'm going to draw the curve now through these points. That's my cos graph and my sine graph on 1. So the red one is sine 2x. The red one is sine 2x. And the cos one, purple one is cos 2x. That's it. That's my graph. So I have my calculator in front of me. Put the values in the calculator. Write them out. For those critical values, those main points. But them, that's a graph. But I go to that. And then now, question says, so those are the graphs. This was just a sketch to show you some stuff. Yeah. Then it says, hence or other ones. Hence means you're going to use a graph. Otherwise means you're going to calculate. Hence or otherwise, solve this equation. This equals that. That's where they meet on the graph. Right? Now, if me in an exam now, and me can actually get these values. So they're talking about these points, you know. The question is asking for these points. Mark them in blue. Asking for this point. I need to know the x value down here. And this point. I need to know the x value right here. So if you want to risk it, you could go and estimate those 2 x values on the graph. Noting that these is in terms of pi. This is in terms of pi. So you have to know, say, there are 3 grids here. So it means right, so pi by each of them you have to divide by 3, right? So it is a pi by 12. It's a 2 pi by 12. And it's a 3 pi by 12. Because what you have to know what each of these little interval is, you have to realize, okay, all 2 years, so it's 3 intervals. I divide each of those intervals by 3. See that? You divide the whole thing by 3. Then. So if all is a pi by 4, and each of these lines have to divide by 3, I take 1/3 of it. Each of these lines is 1/3. So each of them line is a pi by 12. So it's a bit pi by 12. It's a bit 2 pi by 12. I want exactly between pi by 12 and 2 pi by 12 on the graph. But why do when you can work it out and calculate it? Because the question says hence or otherwise. So hence would mean that you have to use a graph, but otherwise means that we're going to calculate it. So the graph would have to estimate what those are, those points, right? I have realized that each of these marks is pi by 12. And it's a 2 pi by 12. And right here, halfway between pi by 12 and 2 pi by 12. You understand that? See? It's like 1.5 pi by 12, right in between. That's all. 1.5 pi by 12, right? Well, let's use the calculation method. So using the calculation method, that's what the otherwise means. It means that they're gonna calculate. So it may have sine of 2x equals cos of 2x by calculation. I can divide both sides by cos of 2x. Because we have an equation with sine and cos. Divide both sides by cos. So you get going to divide this side by cos of 2x. Divide this side by cos of 2x. You get tan of 2x equals 1. And we get tan of 2x equals 1. Now you can draw a quadrant diagram like this. And you want where tan is positive here and there. Two places where tan positive. Right? I must say it's 2x enough. So you're going to have to get twice as many values and then divide by 2. Right? And only are out of the 2 pi. So the principal angle here so is going to be 45 degrees. Or you're working in radians. You're working in radians. So it's pi by 3. So the alpha is going to be tan to the minus 1 of 1. So the alpha is going to be pi by 4, 45 degrees. If you tan to the minus 1 of 1 in the calculator, you're going to get pi by 4. Right? Remember, this quadrant is pi plus alpha. Pi plus alpha. Ready now? So what it means then is that 2x is equal to this first quadrant, which is the pi by 4, and this second quadrant is pi plus pi by 4. So 2x, by the angle is 2x enough. So 2x becomes pi by 4. And this is going to become 5. This becomes 4 over 4. This pi is same as 4 over 4. So the 4 plus 1 is 5. So this one becomes 5 pi by 4. It becomes 5 pi by 4. 5 pi by 4. So divide by this 2 now. So you get x equals pi by 8. And this one becomes 5 pi by 8. So those will be the answers by calculation. That's the otherwise method. So are these correct in the graph? Are those correct on the graph? Let's look on the graph and see them correct, right? Let's look at the graph. So I'm saying, right here, first you have established, since this scale, each of those lines make pi by 4, right? It means that each of these lines is pi by 12. Make sense? So it's a pi by 12, and right, that's going to be 2 pi by 12, right? Or you can say 2 pi by 12 is pi by 6. Or if you want to write 2 pi by 12 if you want. It shall be 3 pi by 12, 4 pi by 12. It shall be 3 pi by 12, 4 pi by 12. Each of them are pi by 12. 5 pi by 12. It's a 6 pi by 12. That's why the pi by 2. It's a 7 pi by 12. And it's a 8 pi by 12. It's a 9 pi by 12. That's why 3 pi by 4. So the two angles where you want is between pi by 12 and 2 pi by 12, don't it? So this angle here, so put it in blue. It's the angle right here, so. It's the average of pi by 12 and 2 pi by 12, don't it? Make sense? So it becomes pi by 12 plus 2 pi by 12 over 2. Average of pi by 12 and 2 pi by 12 over 2. Add up that for me. Pi by 12 and 2 pi by 12 over 2. So it becomes 3 pi by 12, 3 pi by 12 over 2 becomes 3 pi by 24, which becomes pi by 8, which is the same as another person, pi by 8. See that? See that? So write this out pi by 8, right? Write this out pi by 8. So you could have gotten it from the graph. And then this one is right between 7 pi by 12 and 8 pi by 12. Average of 7 pi by 12 and 8 pi by 12. So this one down here, so between the front of the average of 7 pi by 12 and 8 pi by 12, average of them. What I thought I'm going to get. See, right between 7 pi by 12 and 8 pi by 12. That's where they meet. Right between there, so 7 pi by 12 and 8 pi by 12. Average amount of time again. That's 8 and 7, 15. 8 and 7. 8 and 7 are 15 pi by 12. 15 pi by 24. Alright, and then divide each other by what? 3. Divide this by 3, you get 8. Divide this by 3, you get 5. So it's 5 pi by 8. On the graph, the other one is 5 pi by 8. 5 pi by 8. See that? See it? So you gotta get it from graph as well. See that? 5 pi by 8. But the calculation may be easier this time. For the graph and the thing I give you the same answer. So if we get from the graph 5 by 8 and 5 pi by 8. Right? And that is it. Huh? Calculation? Yes, sir. Because the question says hence. Hence means use the graph. Otherwise means you could calculate. So this is the otherwise method right here, so. Which basically is just solve the equation, so. You're solving cos 2x sin 2x equals cos 2x. So once you're solving the sum of sine and cos in our equation, you divide by the cos and form tan. Once you have the equation with the sine and cos in it, and you want to solve it, you divide by the cos and form tan. You get me? See there? So divide this by the cos, you get 1. Divide this by the cos, it form tan. So you know solving tan 2x equals 1. So you go through the normal way. So you draw a quadrant diagram for that between the principal acute angle. So you want where tan is positive here and here. This quadrant is the first one. So the 2x is the angle. So 2x equals this angle equals pi by 4. This quadrant is pi plus the alpha. So it's pi plus pi by 4. So this works out to be 5 pi by 4. Then to get the x now, you divide by 2. So you divide by 2 here, so you get pi by 8. Divide by 2 here, so you get 5 pi by 8. So these are the two answers. They could get it from the graph, or could get it otherwise. Whichever way you want, the graph giving the same answer. 5 by 8 and 5 pi by 8. The graph giving the same two answers. 5 by 8 and 5 pi by 8. We'd have to work down and see what each of these little grids equal in order to know where this is. This is halfway between the pi by 12 and the 2 pi by 3. You have to know where each of these little grids equal. Oh, you know it? Because 3 grids is pi by 4. So each grid is 1/3 of pi by 4, which is pi by 12. So each of those grids is pi by 12. I just add them up. Each grid is pi by 12 across. Each of these grid lengths, this one, is pi by 12. Each of these main grid lengths is pi by 12. That's what you want. Get me? So the graph giving the same answer with the two of them. Cool? All right, down here, so now. Can I come there, so now? This one, so now, use an appropriate double angle. I think this should have said compound. Instead of double, it should have said compound angle. Not double. Because they're asking for a double. So I think this means compound. Why am I saying that? Because they give compound angle on the formula sheet. Formula sheet has a compound angles on them. See that, so? They give the compound angles on the formula sheet. So the one is a question, but you can form the double angles out of the compound angles. And they give you the compound angles on the formula sheet. Right? So they say use an appropriate compound angle. They say double in the question, but you the compound it should be. So what they want to prove is the sine 2x. So use this to prove it. A compound angle. So in the past, we have to know those compound angles. Now they're telling you to prove them. So you see, you have to know how those identities that you're really supposed to know, you have to know how they come about as well. to prove this. So we're gonna use that. Sine of A plus B is equal to sine of A cos of B plus cos of A sine of B. I want to say let A equal B equal X. So this side becomes sine of 2x equals, this becomes sine of x cos of x plus this becomes cos of x sine of x. This is sin x cos x. This is sin x cos x. So it becomes 2 sin x cos x. That's what it is. You should know that's what it is. So I'm telling you to prove something that you should know. All right? Let's make the A and the B equal x. Equal the same. Good? It again. All the double angles can be proven from the compound angles. All of them. They give you the compound angles on the exam paper, in the formula sheet. You're supposed to know it in your head anyway. But let's say you don't know it in your head, because you're not going to exam and depend on formula sheet. I'm telling you, don't do that. See the compound angle them give you there. From those compound angles, you can prove the double angles by making the A and the B equal and add them. Get me? That's how you prove the double angle. You have to prove them from the compound angle. All right? Right now, they're asking us for the sine 2x one. They're asking us for sine 2x. They're asking us to prove sine 2x. Don't be surprised to ask to prove cos 2x on this exam or tan 2x. Whichever one they ask for, they make the A and the B equal. Them say theta, make the A and the B equal theta. Them say x, make the A and the B equal x. You start from these, because these are presented to you. You get me? Good. They're asking us for the sine 2x, right? So you're going to write out this one first with the plus one you want, the plus one. I don't have to look on it, and I know them in my head. You also don't know them in the head too. So if you look on it and copy it down, see, take time to look and copy across. Just write out your head, easier. Write out your head. You don't have to waste time and transpose the information. Next thing you write something wrong. So I want to use the compound, and them say double with a compound angle, them really be sure. So first thing I write out the compound angle that you use. Sine 2x you want, you're going to use a compound angle for sine. It is that the sine of A plus B, that's what is on the formula sheet. It's equal to the sine of A times the cos of B. When you have a plus in a so, you have a plus out so too for cos, the sine compound angle. Then you switch these around now. So become the cos of A now, the cos of A now, and the sine of B. So it's AB, AB, AB. Right? First it's sine cos, then it's cos sine. Then now to prove this double angle, you're gonna let, I'll put it in a different color for you. You're gonna say let the A equal the B and put the two of them equal X. Equal X. The A and the B equal X, then that becomes 2X. So this left side becomes, so this becomes the sine of 2X equals, this becomes X and this becomes X. So that's sine X cos X. Sine X cos X plus, this is X and this is X. Cos X sin X. So we come two of them. So sin X cos X, sin X cos X. Two of them. See that? So you get what it's supposed to be. 2 sin X cos X. That is sine of 2X. Now, since we're here, let me just go for the tan and for the cos. So let's see, just in case. Right? Let me do this. So they've asked you for the tan. Do it with the formula then. They ask you to prove the tan 2x. From right here, sir. They've asked you for the cos 2x, right, sir? So it'll be the cos one, right? They ask for cos 2x, and you use this. Remember, you're using the plus. You have a plus here, so, and you have a plus under this, so. Because for the cos expansion, when up here says a plus, up here says a minus. See that? The reverse sign. So if you're proving for the cos double angle, look what you're going to get. You're going to get the cos of 2x now. If you make the A, you're going to say let A equal B equal X. If you want, if it's theta, you're going to make them equal theta. But the two of them equal the same thing. So inside this now, because it's the plus one you're doing, right? This becomes a 2x. Then this becomes cos x, cos x. See that? See it? Equals cos x, cos x. You're using the minus. Oh, sorry. Because the plus up here, so you're using, you don't have to use the minus up here. So you get minus and it's sin x, sin x. Now, we'll have space. Make this smaller. So it's sin x, sin x. So cos x is cos squared x minus sin x is sin squared x. If you want it in terms of cos alone, you have to change the sin x here to 1 minus cos x. See that? So remember now that the sin x, the sin squared x depends small. The sin squared x can be 1 minus cos squared x, you know. And the cos squared x can be 1 minus sin squared x. So if I'm changing this sin x to 1 minus cos squared x, then I'm going to end up getting 2 cos squared x minus 1. And if I'm changing this cos squared x to 1 minus sin squared x, then I'm going to get, if I'm changing this to this, then I'm going to get, no, sorry, if I'm changing this with this, then I'm going to get 1 minus 2 sin squared x. So the double angle can be written in any one of these three formats. This format, or this format. So in terms of the two of them, this is cos squared minus sin squared. In terms of the cos alone, it's 2 cos squared minus 1. In terms of the sin alone, it's 1 minus 2 cos squared. So one of those three you can use. Now the one, the tan one, don't necessarily zoom in. The one, the tan one now. Tan double angle. Don't necessarily. And put on a use. Again, they're gonna let A equal B equal X. I'm using the plus now. So using the plus, and the plus under this. Right? Using the plus. So you let A and B equal X. Then you go and get tan 2X equal. You're going to get tan X plus tan X up there, so which is 2 tan X, don't it? See that? So you're going to get 2 tan X up here, so write 2 lines for it. Write 2 lines. So you will get tan X plus tan X on the numerator. Tan X plus tan X, if the A and the B equal X, over 1 minus tan X times tan X. It will be tan X times tan X. Cancel the, tan X plus tan X is 2 tan X over tan x times tan x right there. So it's tan squared x. They get 1 minus. Oh, sorry, make a mistake. I should be using the minus. I'm using the plus on top, and the plus on top is a minus that is on top. So it's a minus I'm using. Yeah, so this is the minus I'm supposed to use. My mistake. The minus. So whatever I'm using on top, same thing I'm using on top. So minus. So here now I'll become a tan squared x. That is it. So the CSEC can also prove this one twin for the tan. Same way the component got to be. Just make the A equal to B equal X. I just theta, but then equal theta. And here they could ask for the sign as well. Either one of these. This one, or they could ask for this one in terms of the cost alone, and this one in terms of the sign alone. That is it. That's how we get the double angles from the compound angles. So on this exam paper, 2025, they ask for the sign. And your exam, they could ask for the tan, and they could ask for the cos. That is it. Right? So, wait. I'm going to discuss now. Come back with something. Huh? I'm going to finish the test. I'm going to take a shot. A shot. Can I move now? All right, back to the question, Tony. Them say prove this now. I'm saying hence. Hence means someone's use the result of this, all right? Prove this. Okay, guys, I'm very smart. Sometimes when you're doing the proof, you're working toward what is there. And sometimes you have to force what is there into the operation that you're doing. It will work out itself. At this level, you intend to use your identity one time alone. You're not supposed to use any other identities. Huh? Oh, for the proof, it's easy done. Let's see now. So we're gonna say left hand side. We're gonna say the left hand side become. Now the hence means we're gonna be using this for the double angle right? So right? So the hence. So the left hand side is gonna become 1 plus this becomes 2 sin x cos x over this is sin x plus cos x. But I'm multiplicative. I can turn this one to a sin squared plus cos squared and create a perfect square on the numerator and factorize this out of it. You can do that. Turn this one into a sin squared plus cos squared. All right? Or, because I realize that this result is a sin x plus cos x, I can multiply this by sin x plus cos x over sin x plus cos x and make it work out itself. All right? I want to do both ways. This might be my preferred way. The multiply numerator and denominator by the result that I want. By the result that I want. I make it work out itself. But let's force the other way. And when you know your three identities, you can see through the method that you need to use. All right? I'm going to do it 2 ways. I'm going to shift this over to someone. So I'm going to use the method where I recognize that this one is the same as sin squared plus cos squared, right? Watch this now. So I'm going to write this as sin squared x plus, right back this first, just set it in this particular way, 2 sin x cos x plus cos squared x now. So them 2 here is what my 1 was. I'm set it out that way because I wanted to recognize that this is a quadratic. that can be factorized into a perfect square. Put that all over sin x plus cos x. Now the numerator really is sin x plus cos x all squared, if you look at it, over sin x plus cos x. That's the numerator is really the perfect square of sin x plus cos x. If you factorize this, that's what you're getting. That's it. Well, because I have the 2 sin cos x in this, so that's what I know. So that's what that is. So one of these, each of these cancel with each other. This cancels out one of these, right? This cancels out one of these. And you're left with the right hand side. Sin x plus cos x. See the right hand side. I don't know that a lot of persons would teach to do this. I don't know that a lot of persons will see. You know why? A lot of persons are not going to do it this way. Because we have a simplifying culture in maths. We tend to always be trying to simplify. That's how we normally do. Simplify stuff. We don't really do maths by making things bigger. We don't blow up things in maths. We tend to always do it by simplifying. If you do more like we did a blow up, we turn a simple one. We took a 1. We took a 1 and turn it into a sin squared plus cos squared. I made the numerator look more complicated than it was. Get me? So a lot of persons would do it this way. So let me show you the other way to do it now, which works anyway. Or another way to do it. Because I think again, I might even find another way to do it. Let me do another way over here. So I'm going to start out again by saying the left-hand side is equal to changes to 2 sin theta cos theta. So I'm going to do it that way. So I'm going to have the 1 plus 2 sin theta cos theta. Sin x cos x. Right, that better. Over sin x plus cos x. But the problem is, I have a sin x plus cos x on here. But the final result is a sin x plus cos x, which is really sin x plus cos x over 1. You get me? So I'm going to force it there. I'm going to force it in my operation. I need a sin x plus cos x on top. So I'm going to multiply the numerator with a sin x plus cos x. And so multiply the denominator by the same thing. Sin x plus cos x. Make it work out itself. So I need to simplify all of this part. And all of that must come out to be 1. So that this remains in the end. So I'm not talking that again. See that? I'm going to work on what I've circled and leave this, because this is the answer that I want to remain. So it means that everything in the box is supposed to come out to be 1. You understand? So I'm going to put everything that I've circled together. I'm supposed to cancel out each other. They're supposed to cancel out each other. Get me? So let's go. I'm not going to trouble this. I want this to remain as my answer. So I multiply numerator and denominator by the result that I want to get. And I'm going to work on the rest of it to leave what I want to get. That's the method I'm showing you now. So this becomes equal to 1 plus 2 sin x cos x times this. Remember, I'm not trouble that because I want that to remain as my answer. Sin x plus cos x over. I have to now multiply this times this. But that's a perfect square of sin x plus cos x, don't it? So what does it become? It becomes sin squared x plus 2 sin x cos x plus cos squared x, don't it? I will multiply sin x plus cos x plus times sin x plus cos x. It's really sin x plus cos x all squared by half, don't it? It becomes this. The denominator will multiply these two things. That's what I get. I can see that? I see it? I'm sure. This times this. Give me that. I see it? I see it? I'm going to put another line. Put another line. Put another line. It becomes sin x plus cos x all squared. Then we'll see it now. Then we'll expand it to a perfect square, right? So it becomes equal to 1 plus 2 sin x cos x times sin x plus cos x all over. I'm going to expand this now. First term squared is sin squared x. Who has the product of the two? 2 sin x cos x. Second term squared is cos squared x. See that? Or them two here add to 1. Sin squared plus cos squared is 1. See that? So it becomes equal to 1 plus 2 sin x cos x bracket sin x plus cos x over, and the denominator becomes 1 plus 2 sin x cos x, which this denominator is the same as this part right here. So we cancel each other. And the end result is what I want. Right here. Sin x plus cos x remains, which is the right hand side. So you see, what I did over here is a lot easier, a quicker, less steps than what I did over here. But works, as you see. First method. The first method was just, we say, in order to do the first method, you have to be able to see ahead. This method is a more friendly method in a sense, you know, you do it long time. Right, because you cannot, watch me now, you cannot force the result that you want into it. By multiplying numerator and divided by what you want. And then you know, so okay, now touch this again. Everything is here, so now supposed to work out to 1. You understand? Everything is supposed to work out to 1. So you just leave this here so and adjust the rest and the work out itself. So this method you have a kind of see ahead. It's a see ahead method. This. By this one, you just basically put in where you want and make it work out itself. Alright? That is it. Anything else on this question? Want to do the vector part? I'm not good with that. Somebody come, push the door. Huh? Go to the vector part. Go to the vector. That finished that question. All right. Tell me, I take a look at 5 minutes break, after 10 minutes break, come back on the same model there. All right? I don't want me to do question 4 first on the paper. Huh? Just do, eh? Question 3 done. Question 3 is a vector, but some don't need the vector. You don't need the vectors. You want to see the vectors? Or the vectors? Vectors are the easiest topic in our CSEC, in our maths, you know, easier than CSEC vectors, you know. You never know. Allow me to tell. Advanced vectors easier than CSEC vectors, man. Don't tell no lie, man. It's too easy, man. Let's go. It said the portion vectors of A and B are these. The portion vectors of 2 points A and B, where the coordinates are these, are OA and OB. So if they give you this point, look, if they give you the coordinates, you automatically know the portion vector. So you automatically know that OA is this vector, 2, 3. And OB is this vector, minus 3, 2. If you want to write them in terms of I and J like this, it means that OA is 2I plus 3J. And OB OB using these values minus 3i plus 2j. Now, when I'm doing vectors, I'm doing my calculation. I prefer to work with the column vectors. So I don't have the I and the j all over the place. You get me? I like to work with my column vectors. I can clearly see my x values and clearly see my y values, or my I component and my j component. When I'm giving my answers, if they require it in I and j, I give it now answer in I and j. But I prefer to work using these. Easier. Right? Question wants us to find a vector AB. Easy. AB is O times the last minus O times the first. OA minus OB. So it is this vector minus this vector. You want me to do the question and pay attention. Okay, so the B minus the A. Simple as that. Right? So we basically subtract them. So then this value minus this value becomes a negative 5. Negative 3 minus 2 is negative 5. And 2 minus 3. 2 minus 3 is negative 1. The want in terms of I and J, so I'm going to write it as minus 5i minus J, minus 1J. Minus 1J is minus J. That's it. So that is the vector AB right here. The B minus A. The minus 3 minus 2, give a minus 5, and then 2 minus 3 is negative 1. Right? If you want to put a 1 right in front of the J, fine. But that is it. Then I want the angle OAB. So, using yeah, man, if I use these two, man, if I use these two. So you could have done this minus this same way, and then you could have done this minus this same way, no problem. But I prefer work with a column vector without the J, and then right by the J, because it's easier to see the values I'm going to get mixed up. Especially when you put them side by side. Because even this one, could I write this one and put them side by side, like minus 3, 2, minus 2, 3. And you would see that it is minus 5, minus 1, clearly. You get me? Just easier. All right, so down here now, the more the angle AOB, eh? So the angle between the vector OA and the vector OB. So like you have O here, you have A up here, so. And so you want the angle between the vector O to A and O to B. You want this angle here. So the angle between two vectors, the angle between them, when they're both diverging or both converging. So we want to use OA and OB to find that angle. Understand? You want two diverging vectors, two converging vectors. So watch this now. We call it an angle theta, right? It's quite simple. Watch this now. Theta equals cos to the minus 1 of the scalar product over the modulus product. The scalar product is OA dot OB. No? Oh, I think it is. But this is not hard to know, my youth. Oh, see that so. Yes, see that so. That depends on formula. You have to take space time to look. It's better when you're in your head. Why you think you forget? Scalar product over modulus product. Why you forget that? Scalar product over modulus product. Scalar product over modulus product. Cos to the minus 1 of a scalar product over the modulus product. You can't forget that, man. You can put that image in your brain. Scalar product over the modulus upon the bottom part. Scalar product over modulus product. So the modulus of OA times the modulus of OB. That always is the angle between two vectors. Scalar product over modulus product. Cos to the minus 1 of a scalar product over modulus product. So that angle theta equals cos to the minus 1. What's the scalar? Let's write them out. Remember, OA is what? OA is 2, 3. And OB is negative 3, 8. Still going to be 0. So this product first. This time this is that value first, right? With the scalar product. So this time this first, which is 2 times negative 3. Plus this time is 3 times 2. That is 0 now. Over the modulus product. So I write the square root of the 2 squared plus the 3 squared. and the square root of this modulus of this one. 3 squared and 2 squared again. What is up here? So 0. That's all. So 0. So theta equals cos to the minus 1 of 0, which is 90 degrees. And you should know that when the scalar product is 0, down between them is 90 degrees. So once you get scalar product equals 0, them 90 degrees apart. So see the relationship between them. They are perpendicular. 90 degrees. They're perpendicular. So we're doing CSEC vectors. The law of the questions are mostly about parallel vectors and polynomial. At maths, questions are about perpendicular vectors and angle between them. That is not vectors that are not bound in a sense. Let's say that. Get me? The perpendicular. Because this up here so is 0. Alright? So the scalar product. So it don't matter what this work out to be. All you know that upper side is 0. You can write it if you want. Plus the minus 1 of 0 over. This becomes 9 and 4. 13. And it's a 9 and 4 too. So it becomes root 13 times root 13. Alright, which becomes cos to the minus 1 of 0, which is 90 degrees. Right? That is it. Alright, that is it. So first time done. So, alright, so break and then come back to this. Take a little break and come back to this. Alright, take a little break. Put up the clock. Oh, go on 15 minutes. 15 minutes. What the fuck? Yeah. Huh? Maybe I was step down. The training side ready. How can you go through? Yeah, it's about the I'm down 5 minutes. I'm down 5 minutes. Time up when I come back in. All right. Put down 5 more minutes. And we're definitely starting after 5 minutes. Jordan. Huh? 2 seconds. Right. All right. So the start number 4. The three roots lahat sa paano siya. Ang mga ito very simple. Remember, if you know the roots, you know the function, you know, if you know, if they give you the roots, you automatically know the factors. That's it. Right? They give you the roots, you automatically know the factors. All right. So back to this case. So I want us to do this number 4, right? All right. So I want us to differentiate these. But a trig, so I write this as a power function. Right? So I'm gonna write it as y equals sine of 4x plus 3x to the negative 4. So that when we differentiate sine, I get cos. We have to remember to also differentiate the 4x. I get 4. And so if you differentiate in this term by term, ui by dx is simple. Differentiate the 4x first, I get 4. I differentiate the sine 4x in a sense, I get it cos of 4x. You're differentiating this now, the same process. Multiply by the 4, you're gonna get minus 12. X reduces 4 by 1, you're gonna get minus 5. Give them back as they gave it to you. So it becomes 4 plus 4x minus 12 over x to the power of 5. That's it. But you go to that? Huh? Pay attention as I write it. And when you try write, it make me go waste time. Let's get the explanation first. And this is being recorded, and I can go back and watch it over later and do what you're doing. It's a tomorrow. We're going to take time to look over those. So yeah, right. Make the session efficient, guys. I have to make it efficient by paying attention. All right. So first thing, you have to write it as a power function. Right? Write it as a power. You can write it as a power function, write it as a power function, meaning x to some 4. So I'm write it as 4 y equals sine of 4x. That's this. Here's this. Sine of 4x. Plus, I'm going to write this as 3 times x to the minus 4. Understand that? So dy by dx equal. Now, we differentiate sign, you get cos generally. But you have to also differentiate the function that is inside the sign, which is 4. So differentiate 4x, I'm going to get 4. And I'm differentiating the whole thing, which is sine. Differentiate sine, I get cos. I'm going to get cos of the scale 4x. So differentiating this now, the same multiply by the power of negative 4, it becomes minus 12. Because negative 4 times 3 negative 12 times x reduces 4 by 1 to negative 5. Okay, they gave us this like this. I'm going to give them back the answer in a similar way. 4 plus 4x minus 12 over x to the power of 5. That is what dy by dx is. Cool? Down here, it says determine the coordinates of a stationary point. You know, at a stationary point, what do you know about a stationary point? Dy by dx. is equal to 0. So all we have to do is differentiate this, put it equal 0, and solve. Right? So from this now, we're going to differentiate first. So the dy by dx becomes equal to, you differentiate this, multiply by 3, you're going to get x squared, right? And the 3 cancels 1/3, give you x squared. Differentiate this, 2 cancels this 2, we're going to get 5x, I get minus 5x. Differentiate 4x, I get 4. Differentiate a constant, that is 0. That's dy by dx.
Sir,
Put it equal, yes?
I'm just seeing the time.
You want to
And
see the time?
yes, I'm only seeing the time, not the.
Oh Lord, sorry about that. Hold on. So that means I need to stop sharing and then start sharing. Hold on a second. This thing always happens, put on the time and I don't know why. Something that always happens when I put on the time. Um, every time I put on the time, it sticks up. Sorry about that. Yeah. So my work over to stand in. Sorry about that. Seeing it now? Seeing it now?
Yes, sir.
All right, let me do over this one for you, cuz. Let me do over this one more time. More maths equals better maths. So let's do it over. Sometimes I realize that every time I put on the time, short stuff, life. All right, so I want to differentiate this function. I want to write this part of it as a power function first. So I'm going to write this whole thing as y equals sine of 4x plus 3x to the negative 4. 3x to the negative 4. So I bring this up and put it as x to the negative 4. Then I'm going to differentiate dy by dx equals. When I differentiate sine, I generally get cos. But I also have to differentiate the function within the sine, within the tree. So I differentiate that 4x, like a chain rule situation. If I differentiate 4x, I get 4. 4. When I differentiate the whole of sine, I get cos of 4x. We'll put context in this, cos of the same thing there. That's the differential of that is that one. Then now I differentiate this one now, the power function. So I multiply by this power, I want to get minus 4 times 3 is negative 12 times x reduces 4 by 1 to negative 5. And basically, that is it. Because they gave me this way, I'm going to give it back to them. Because this is simplified, even back with the how they gave us. So it's 4 cos of 4x minus 12 over x to the power of 5. That's what this means. Comes under here with the positive power of 5. That is it. Right? Then on here, it says you have to determine the coordinates, and coordinates mean plural. We find the x and the y value at the coordinates. That's what coordinates mean, both values. At the stationary points, at the stationary points, we all know that the gradient dy by dx is equal to 0. So to do this, we have to differentiate this function, get the gradient function, and put it equal to 0. So we're going to differentiate this. Dy by dx becomes equal to, when we differentiate this term, we multiply this 3 by this 1/3, it becomes 1. Reduce the power by 1 to square to 2, so it becomes x squared. Then differentiating this one, multiply by this 2, 2 cancels that 2 under there, so that is gone. We're left with 5, so it becomes 5x minus 5x. When you differentiate this 4x, it becomes 4. Differentiate this constant negative half, it becomes 0. So putting where this equals 0 for the stationary points. So we really know trying to solve right here. To get those x values at the stationary point. Now, this can be factorized easily. X and 1 and 4 signs are the same, they are both negative. So we are getting x equals 1, x equals 4. We're not done it. Those are just the x values. It said coordinates. So to plug these x values now into the function to work out those y values. All right? So let's go. So for this one, y is equal to plug in 1 in this function. So it becomes a third times 1 cubed minus 5 over 2 times 1 squared plus 4 times 1 minus half. Okay, I would have thought the calculator. And then for this one, I'm going to plug the y in there again. Plug x in this one to get the y. So in that case, the y becomes equal to a third times 4 cubed minus 5 over 2 times 4 squared plus 4 times 4 and subtract half. So you get the y value there. So it's a calculator job now, bad. Calculator job. So I'm getting a third times, that's 1 cubed. I'm putting it there because I'm going to change it to the 4 afterwards. Minus to get the 4. 5 over 2, that's times 1 squared. And that's plus 4 plus 4 times 1. And then we're subtracting half. And that gives us 1.33, which I guess is 1/3 of 4 over 3. So this is 4 over 3. So 1 point is 1 over 3. That's 1 point. Other point is over here. I'm going to go back to the calculator and just change these ones to 4. Change these ones to 4. Change this one, 4. And then make sure the same thing says 1/3 4 cubed minus 5 over 2 4 squared minus plus 4 times 4 minus half. Good. And that's giving us minus 19 over 6. Minus 19 over 6. So the second point is 4 negative 9 over 6. Those are your two stationary points. And they didn't ask us for the nature. Just wanted the coordinates. Do they want the nature down? Yes, they want the nature. So to get the nature, we need the second derivative and determine the nature of each. Now, looking at this one has a higher y value, so I would say that this one is the maximum, this one is the minimum. Also, this is a cubic function where the cubic term is positive. So you know that the curve will shape like this. When the a is negative, when the a is positive in a cubic function, the cube term is positive. The maximum comes before the minimum. So this is going to be the max, that's going to be the min. So you know that already, but we still have to work it out. All right, but at least you know what you're going to get. So let's go down here and do the second derivative. So for the nature, which is maximum or minimum, we need the sine of d2y by dx squared. And so we have to differentiate this again, this dy by dx. All right, so you differentiate this inside, you're going to get 2x minus 5. Or differentiate the 4, get 0. So differentiate is going to get 2x minus 5. So d2 by dx is 2x minus 5. Then at the point, what was it again? It was 1 over 3. 1 over 3. Where the x value is 1. The d2y by dx squared becomes 2 times 1 minus 3, minus 5, sorry. Which is a negative, choose it less than 0. Therefore, it's a maximum. We knew it was 1 over 3 is a maximum stationary point. And at the other point, which was what? 4 negative 19 over 6. Negative 19 over 6. The d2y by dx squared becomes 2 times negative 19 over 6 minus 5, which is clearly less than 0, which therefore means that this point 419 over 6 is a minimum. Max means maximum, min means minimum. All right? This one down here now is a connected rate of change. You have to learn how to set up a rate of change. And sometimes they will give you a shape in the question that has to do with area, perimeter, volume, something like that that relates the variables. You have to create that relationship and differentiate it. They're not going to tell you have to do it. So we're talking about a cylinder. You might talk about it might be the surface of a cylinder, might be the volume of a cylinder. There's a formula for those. Right? If the sphere, volume of a sphere, surface area of a sphere, the formula for it. It's a triangle, whatever the shape is, they're going to give you some standard object or shape that, you know, setting up a formula for one of the measurements and one of the geometric measurements, and you have to differentiate. They want to connect those variables. All right, let's see what it says. It says the length of the edge of a cube. All right, so we're working on a cube. A cube has 6 squares on the sides, right? A cube. So we can make a sketch of a cube. So we're working on a cube. Can draw a cube quickly like this. Like so. And do another one like so. And then draw them here, so. We can change the color of the back so we can pick it up. So that's inside the back. All right. So you see that cube right in the back. That's a cube, right? That's what it says. So you know, working the visual. So it says the length of each edge of a cube is increasing at a rate of 0.2. They did not give us a name of the length of it. So we're going to call it x. Let's just call each edge x. So x by x by x. And they said the length of it, which is dx by dt, that's dx by dt. See? X is in centimeters, the s is in time. So this information is dx by dt. Dx by dt, the constant rate of 0.25 centimeters per second. Centimeters per second. So it's calculate the rate of change of the volume. So watch it now. Shift this over. So this is given. This is what is required. What is the rate of change of the volume? At the instant when the length is x. So this is when x equals 8. What is this asking us for? It's asking us for dv by dt. That's what this question is asking us to find. dv by dt. So we need the formula for volume in terms of these values. So we can connect the rates of change. To find dv by dt, we do have the formula connecting the v and the t. So we have to connect the rates of change to find dv by dt. We can establish a relationship between the volume and the x, the length and this cube. So see down here now, that's what you have to know that you have to put it. You have to add that to the information. They're not going to tell you that until that you need to do it. You have to know say you need to do it. You need a relationship connecting the volume and the length. Volume of a cube is x times x times x cubed. So that volume is x cubed. And if the length is changing, then the volume is changing. And the rate of change of the volume, dv by dt, you differentiate this, it becomes 3x squared. That's the rate of change of the volume. And this is what we want, dv by dt. All right? So therefore, dV by dt that we're trying to find is the product of two rates of change. These are the two rates of change that we have. We have to connect them with the chain rule. So you do it. You put the dV on top of the first fraction there. Put the dV on the bottom of the second one. And the third variable is x. You put it up here and down here. And put a different color so that you put it in last. You put the dx right here and the dx right here. So you need to multiply dV by dx, which is this, and dx by dt, which is that. So it becomes very easy. And then says when x equals 8. So this all then becomes equal to 3x squared times 0.25. And it's when x equals 8. So that's dV by dt equal to that. So when x equals 8, that's what they said. When the length is 8, x equals 8. That dV by dt is 3 times 8 squared times 0.25. Answer. And because of the volume you're doing, you have to put cm cube per second. Time is in seconds. All right, so working this out with the calculator. So this is 3 times 8 squared times 0.25. That's 48 centimeters cube. The volume is in centimeters cube per second. S to the minus 1. That is it. And so look what we can like this, guys. The shape, you have to introduce the shape and set up the relationship in dimension. What? Your volume is in same cube. If it's rate of change of the area you want it, you'll find. Suppose this question says find the rate of change of the area. You have to know that the area now, suppose this was area, you don't know so the area of this thing is 6 times x squared. And then dA by dx, what I call 12x. And then the dA by dt would be the dA by dx times the dx by dt. So they could have the rate of change of the area to it. So they use the area relationship. You understand? If the question wanted the rate of change of the area, that's what you do instead. And then when you work this out, you have put 12x times 0.25 here, so you have a 3x. That's all. It's a quarter of 12. See that? And you put in the 8. X equals 8 same here. Let's assume x equals 8. That will equal to 24. You have to put centimeters squared now as its area per second. If they wanted area, see, what? Those are the area they wanted. That's so they can answer anything. Shall leave us on it then. Don't. Let me leave it on it. Let's leave it on it. On there. If it was there. Register. If they wanted area, that is what you have to do. If they wanted area. Alright. That's what you have to do. If the person wanted area. Alright, so that finishes that question. Alright, which other question you say you want? Alright, let's see something. So Dominic said it. Maybe Dominic one and then first one now. So Dominic sent me a circle question, a month. Which is a question 3. But I just did the sign and cast 1 hour ago. Draw the 2 graph, right? Let's switch that one even. And I did the one with the surds. I did the rational. I'll do a couple of your questions them already. So the circle one, I want to know. But which paper is that? I don't know which paper. Let's look at the 2024 paper. Yeah, let's look at the 2024. All right, let's look at the 2024 paper. So far we're toggling between 2025 and 2024, right? No problem. Because the standard of the exam is the same. That's the beauty about admits, guys. We do a lot of past papers, you can find. Because basically set the question the same all the time. Set the question the same way all the time. Watch it. You don't really change the level of difficulty much. I tend to ask for the same things all the time. This one, right? This one to determine the point of intersection of this circle with this line. The simultaneous equation that we do one earlier, right? So all you do, you take this subject for the y, right? That's all. All right, that's all. Get a quadratic, expand it out, and solve for x. When we expand in the perfect square now, right? That's all. You get x minus 6 squared there, so it becomes x squared minus 12x plus 36. That's all for the perfect square. Get a quadratic, and after you get x values, now you substitute back x values then up in the line equation. You get the y values. All right, so that's not what you want. All right, so this one is something that we just did. Like what we just did. I'm sure if we not on this one. All right, look at 2023. This one here, something like this I want. You just have to put the center and the radius. Huh? So 2023. So for this one, the method I use is to complete the square, get it in the form x minus a squared plus y minus b squared equals the radius squared. Huh? That's the method I use for this. So I want to get this. The method I use, that ways to do it without doing that way. But that's the method. That is a formula that you can use. Some GF business that they teach. Right? Forget in the center. Huh? Negative 2f and negative 2j. Yeah, but there's a method. I use my method to complete the square and get the equation. So I want to get this equation in the form. Get this equation in the form x minus a squared plus y minus b squared equals the radius squared. Get this to look like that. When I get it to look like that, it means then that my center point is AB and my radius is R. Center is AB and my radius is R. The key thing is that is x minus that must be in the bracket, guys. So then put a plus, you end up with a plus in there, put the minus minus B, right? It's x minus A, x minus B. All right. So I'm going to complete the square of this. I'm going to take this equation and write it in this form by completing the square of the x terms and the y terms. All right. So put the x values together. So it's x squared minus 8x. Put the y values together. Y squared minus 18y. I can transpose the 93. I can leave it. No problem. plus 93. I can't go. Equals negative 93. So the 93 go over and become negative 93. I complete the square of these two and these two now already. So to complete the square of these two, there's no factorization needed. So it becomes x and half of this negative 8 is negative 4 squared minus the square of this. Remember to subtract the square of this, which is 16. Plus the same thing with this one. Y and half of this is negative 9 squared minus the square of 9 is 81. That's all equal to negative 93. What did I do? I put half of this value here minus the square of this value there. Same thing. Half of this value goes here and you subtract the square of this value here. That's how we complete the square. So simplify. Now this and this equal how much? How much is that? That's 97, not it? When it goes over, it becomes a positive 97, right? 97 minus 3 is going to be 4, right? Now come over, is about plus 97. The 97 and the minus 93, that's how it becomes 4, right? So I'm going to get x minus 4 squared plus y minus 9 squared equals 4. But I said I'm going to get a 4 on the right side. But the 4 is 2 squared. See that? So I'm going to have it in this format. So it means that my center means that this is my A, this is my B, this is my R. See? So the center point, Newton my is online, AB is 4, 9, and my radius R is equal to 4 units. I mean, radius is a length, or distance. So the radius is 4 units. Newton my is all right. But I go to that. Now remember, if this ended up with a plus here, so for example, then the A will be negative 4. Negative 4. You understand? Okay, it's supposed to have x minus. So if you end up with a plus here, so it's like it becomes x minus negative 4. So the A will be negative 4. That you get me? So that's a key thing you have to look out for. That is it. Then let's find the length of the radius. We'll have it here. So the first part I want to the center, second part I want the radius. So we cannot stop with this down. So. All right? Then it's now find the equation of the normal at the point 2, 8. Sometimes I ask for normal, sometimes I ask for tangent. I tell people all the time, when you're doing the equation of circles, normal is the best friend or your better friend. You know normal and the tangent at the point, the normal is the better friend because you know more about the normal than you do about the tangent. But the normal will always pass to the center. All right? So that point is what? 4, 9 versus 2, 8. So like we have the circle and the center point is 4, 9. Whatever point here is a 2, 8. This question is asking us for the normal. That's this. We can sometimes extend out here. That's a normal. Draw it another way. And sometimes they will ask us instead for the tangent. Something like this. Like that. All right? So sometimes they ask us for the tangent, guys. I'm going to do both. Key thing that they are perpendicular. But whether they want the tangent or the normal, you have to work with the normal first. If I say you have 2 points that the normal pass through. Let's call this point that the pass through P for reference, P. So that's coordinates of P. This point here, we're calling it P. All right? So we need a gradient to find the equation. To find the equation, we need a gradient and the point. We know the point. Let's work on the normal first. The normal is in purple. The gradient of the normal is the gradient between these 2 points, the center point and that point, because normal passes to the center. So remember, the difference in the y values, which is 9 minus 8. 9 minus 8 over the difference in the x value, which is 4 minus 2. Over 4 minus 2. Right? That becomes 1 over 2. And the point of tangent is this one. So the equation of that normal, the y minus the y value at the point equals the greater of the normal into x minus the x value at the point. If you don't want to use the method, you can use the y equals mx plus c, plug the m here for the half, and then put the point in there. So put the point in the equation to find the, put the x and the y value in there to find the c. Right? You can do it that way as well if you want, but I don't use that method. I use this method because this method gives the equation straight away. So it's y minus the y value at the point is 8 equal the greater of the normal is a half into x minus the x value at the point right here is 2. So it's y minus 8 equals, take the half and distribute it on that bracket, get half x minus 1. We carry 8 over, becomes a plus 8. We're going to get y equals half x. So let's go the x. Right, I'm going to get half x plus 7. That becomes the equation of the norm. Right? In this case, we can do the tangent down here. So suppose I wanted the tangent instead. Tangent. Let's do it here. So suppose I wanted the tangent. Gradient of a tangent will be minus 1 over the gradient of the normal, which in this case will be negative 2 because the gradient of a normal is a half. You flip the half and change the sign. It becomes 2. Negative 2. Flip the half first, it becomes 2. Change the sign to negative 2. Then the equation will be set up just like the normal. It will be y minus yp, because remember the tangent pass to the same point, p, equal to the gradient of a tangent now into x minus xp. Most times the half of the tangent. Most times. This gets some half for the gradient of the tangent. Most times. All right? Let me shift this up a bit. And so you plug the values in there now. It will be y minus y value at the point is still 8. Gradient of the tangent is negative 2 right here. The x minus x value at the point is this 2 still 2. And so it will be y equals, let's write it out now, minus 2x. Minus 2 and the minus 2 is positive 4. Then the minus 8 goes over, add to the 4 and give me 12. So it will be minus 2x plus 12. It will be the equation of a tangent if they wanted it. But this is the answer to the question. This is the answer to the question. If they wanted the tangent, we do the operation down here, right? If the question wanted a tangent. Most time they want a tangent. And that's how this question is done basically all the time. They don't know how to way. Work with the normal first to get the gradient. If they never ask for the equation, but just use the gradient right there, so and drop it and get the tangent gradient from it. Right after. Don't bother with this work. If they did not want the equation, I still have to find the gradient of the norm first. Right? That's the method we use. That's the easy way to do it. Right? It's the easy way to do it. All right, that is that. Huh? Another one like this again? You know, trust yourself. All right. Let me see this one on 2022. Got to cover the practical every exam paper. You don't trust yourself. God. 2022. All right, let's see. Common practically every exam paper. So, anyway, so this look, same thing we're gonna do, different things. Same thing. They give you this equation, right? So this company example, you're gonna have to kill it, you know. Can't lose marks after this, I show marks best than this. They give you the equation again, right? And they ask you to find the center and the radius. I give you a question that came on the pure maths paper this year. They actually give you 2 points and the diameter and ask for the equation, the circle, on the pure maths paper, which to me is the hard maths level work. Remember, if they give you information to find the equation of a circle, you just need to find where the center is and the radius. So the information you need, find the centers. But I'm telling you the diameter, the endpoint. You can find the midpoint, which is the center. And the distance from the center to the point and the circumference is the radius. And when you put them in the equation, in the form, x minus a squared plus y minus b squared equal r squared expanded, right? But I'm going to do a question on the pure maths paper that they said this year, and I'll show you. Where they gave 2 points on the diameter. I'm going to show you a neat way to do it. You can't find. But anyway, they give this, I don't want the center and the radius. Same thing. When I get this in the form, get this equation in the form x minus a squared plus y minus b squared equals the radius squared. The center will be AB and the radius will be R. All right? So again, you're going to compute square these values first. Full amount, x squared and 4x, y squared and minus 8y. Y squared minus 8y. Now, if you know your FG formula, FG and C formula, you can use it enough. There's a formula to find the midpoint. And the center and the formula to find the radius. If you know that method, no problem, use it. I want to care about the 10 and put negative 10 over it. It's 10. We need to want to put the negative 10. Complete the square of these two terms now. X half of 4 is 2. Squared. You subtract the square of this 2, which is 4. The same thing here, so. Plus y. Half of minus 8 is negative 4. Squared out here, so. Subtract the square of the negative 4, which is 16. Equals. It's negative 10 on the right side. What did I do? Same thing as before. Half of this value goes here. Subtract the square of that value. So you see, it doesn't matter whether the sign is positive or negative. You are subtracting the square of the value. All right? But like reverse expanding a perfect square. Same thing here. So half of it goes here. Subtract the square out here. It's simplifying. So you're gonna get x plus 2 squared plus y minus 4 squared. Or this and this is negative 20. Negative 20 come over here at positive 20. Huh? Yeah. I never do already. That's a load already. Right, like us, I never do already. So it becomes a 10 on the right side, right? You want a square. So because you want a square, what you can do, you can square root it and square it back. Because 10 is not a square number. So it means then, this and this. Your A is negative 2. Your B is 4. And your R is the square root of 10. See that now? I did negative 4 come over plus right instead this time. So plus is the same as minus minus. So that's why the A is negative 2. Alright? Be careful when we have plus inside. So based on that then, center point, negative 2, 4. Radius is R equals the square root of 10 units. That's it. Then they want to find the equation of the tangent at this point. Same thing. So then just make a sketch, you can see it. So what you're doing. Nobody work it blind. I always make a sketch. So I'm not working blind. So I'm gonna make a sketch of a circle. I'm gonna put in my center point, which is negative 2, 4 right here. Negative 2, 4, and then negative 5, negative 5, 5 will move up here. So this is negative 2, 4. And this might be negative 5. So let me call it P first this time. Good. It's negative 5, 4, negative 5, 5, sorry. So then, normal is my best friend. We put this negative 5, 5 somewhere else. I draw them in first. So this is my normal, best friend. I'm a better friend. Put an N on it for normal. But it's the tangent that I want. I want this. T for tangent. T for tangent. They are perpendicular. And the point P right here, negative 5, 5. All right, negative 5, 5 is that point. All right. Still the normal has to help me again. Can't get to the tangent without the normal. And the normal, we have more information about it. Pass through 2 points, so we can find the gradient of the norm. So the gradient of the norm, the difference in y by the difference in x between those 2 points. So it's 4 minus 5 over negative 2 minus a negative 5. Negative 2 minus negative 5. So minus becomes a plus. See that? So it becomes equal to negative 1 over, this is a positive 5 minus 2, that's 3. Negative 1 over 3. And if that is the gradient of the normal, then I can get the gradient of a tangent. Gradient of a tangent then is minus 1 over the gradient, positive 3, over the gradient of a normal. So you flip this and change the sign, it becomes a positive 3. So using this gradient and this point, not find the gradient of that red tangent. So tangent equation. So y minus yp equals gradient of a tangent into x minus xp. So it's y minus the y value of the p is 5. Gradient is 3. The x minus x value is negative 5, so for careful use. So subtracting a negative 5. So this minus minus here becomes a plus. It's got a small plus on it. So that's really a plus. So careful now. So it is y minus 5 equals 3 times x is 3x, or 3 times positive 5 is positive 15. Then this 5 comes over and add to the 15, give me 20. So it's y equals 3x plus 20. That is the answer for the bit of a tangent. Yeah, me if no more this too much. Too easy. All right. Anything else? You said I want to know. All right, Dominic, let me see if I can find. So you're good now. The question that you sent me was similar to this one. All right. And online, anybody want to send any have any question I want to do? Online, people in here like them run out of question. You want to question? Somebody, me? I know all of them use me, but I have food. What I'll do afterwards, I'll bring up the syllabus and go through it and see if I can pick up one or two stuff where really come. Just to again give you an example. Oh, I said I was going to show the 2025 pyramid. Eh? Right, rate of change. Oh, the motion straight line. That's model 3. That's model 3. Don't want to do it yet. Soon got to it. But let me show you something. Well, that's a model 3 to the tricks. I'm gonna show you something I want to show you. Let me show you something. Watch this now. I'll show you like this. Suppose I ask you, pay attention, you. Suppose I ask you to find the exact value of the cost of, for example, 7 pi by 12. 7 pi by 12. I go cheat yesterday. Right? Or I could ask you for like the sine of pi by 12. You see them kind of number there? No, the one you show it. It's 1 4, right? I don't want the exact one. So if you realize the 7 is 3 pi by 12 plus 4 pi by 12. So you could write this as the cost. No, but you have to think. You have to write this as, no, you have to work, you have to show the working. Yeah, so this becomes the cost of 3 pi by 12 plus 4 pi by 12. It becomes the cost. Now this 3 pi by 12 is actually pi by 4. Plus this is pi by 3. The compound angle on this now is cos minus sin. So it's the cos pi by 4, cos pi by 3, minus sin pi by 4. No, not pi by 4. Oh, my mistake. Yeah. Sin pi by 4, sin pi by 3. Yeah, right. Sin pi by 3. But the cos of pi by 4 is root 2 over 2 times cos of pi by 3 is a half minus sin of pi by 4 is also root 2 over 2. Sin of pi by 3 is root 3 over 2. The question is easy when you know these things. So this one becomes root 2 over 4 minus this one becomes root 6 over 4. So it becomes root 2 minus root 6 over 4. See that? Now if it was this one, for example, over here, son, let's say I wanted this sine of pi by 12. Let's say I wanted the sine of pi by 12. And the sine of pi by 12 will be the sine of 4 pi by 12 minus 3 pi by 12. See that? 4 minus 3 is 1. And then becomes the sine of pi by 3 minus pi by 4. So it's a function of sine now. Sine called sine. So it will be sine pi by 3 cos pi by 4. Whatever sine is in here comes out here and the expanded form. Cos pi by 3 sine pi by 4. It's in the variable. Sine of pi by 3 is root 3 over 2. Cos of pi by 4 is root 2 over 2. Cos of pi by 3, eh? Eh? Got a charger? Yeah. Cos of pi by 3, the half, that's 60 degrees. And the sine of pi by 4 is root 2 over 2. So it becomes root 6 over 4 minus root 2 over 4. So it becomes root 6 minus root 2 all over 4. Alright, so they like giving questions like this. Well, they used to give questions like this a lot in the past, but we never see a lot of it. That's happening. Come. Try this. Sure, something. That's not what it is. Serve. If you are served. And I give it a diameter. 2 endpoints on the diameter. I can get the equation of a circle without doing the center with it. You can get it quick. I'll show you, right? I gave it on the pyramid paper this year. I can't find the pyramid paper. You can find 2026. But I'll take this off and price. The bar go to the side. That's what the policy. And sure enough, for the request, them ask it like that. They give you endpoints from the diameter. Ask for the equation of the circle. Right? I'll show you how can be. 2020, 2025. 25. Stop showing. You're tired, dude. You're tired. Here's the thing, man. Where's it? So 2026. See paper here. This is the 2026 exam, right? See the 2026 exam. All right, some of these questions you guys can do. Rationalize the denominator. All right? Rationalize the denominator. That's not an syllabus. Them say this is a factor. Look at this. You guys can listen. This is a factor of that. Find Q. Means that f of minus 3 equals 0, right? See that? And them say factorize it. So if this is a factor, you go and divide, right? With x plus 2. Right? With x plus 3, sorry. X plus 3 is a factor, divide. Then them say now, when this is divided by that, what's the remainder? Remainder is f of a half, right? Right? If you divide something by 2x minus 1, the remainder is f of a half. Because you put this equals 0, you get x equals half, right? F of a half. Right? So what is the remainder when this is divided by that? This is the same as 2 into x minus half. Or some teachers do it this way. They put this equals 0, to find what they want f of what? The x equals half. So the remainder is equal to f of half. So you put half in this, and whatever that work out is the remainder. So you get a half to the 4th power minus 2 times half squared plus half plus 1. Whatever that work out is the remainder. That's why I set this on a pyramid paper. Right? Easy stuff. Right? All right. Then I get this table to fill out and draw one graph and a pyramid exam. Ridiculous. Open the paper come easy like this. Then I give this to modulus. Just reflect the negative part, and those are straight lines. This paper was just ridiculous. They give this function for them to find the inverse. See that up? Find the inverse, which is CSEC. To find the inverse of this function, is CSEC. 5 marks for doing it. 5 marks for doing it. I don't think they give so much in CSEC for doing it. 5 marks. Find the inverse of that function. CSEC get that as well. Ridiculously easy. Then I give this indices to solve, which you can do. Take logs on both sides. When this ball come to the front. It can be 3 to 11. So 3 to 11 power. Right, so this equal that. Or they don't know that if they log on both sides, log this side and log the side. They bring the power come to the front. That's solved. But anyway, that's not what I'm looking for. Yeah, but easy logs are to do as well. Eating with this guy, remember now with logs. Eating with this one, I can do this one for you and show you something. Is that when you get a logs equation to solve, you get the answer. You must always check the answers can work in the original equation, but you can't find a log of a negative number. So if I'm doing this one for you, which can come on an admits, the sum of logs become the log of the product, right? So this becomes the log to base 2 of x plus 6 times x plus 2, and that's equal to 5. So this is the number equal to the base raised to that power. So if you're looking at the rules or the conversion from logs to indices, it is this. Log of a number to a base is equal to a power. This number is equal to this base raised to that power. In this case, this is our number, it's our base, it's our power. Right? So we can therefore say that this number right here is x plus 6 times x plus 2 is equal to 2 raised to the power 5. 2 raised to the power 5 is 32. So I'll expand this out now. I'm going to get x squared plus 8x plus 16 equals 32. Right? So we get 8x, power product and the near product after 8x, right? 8x. So you're going to be x squared plus 8x. That's going to be minus 20 equals 0. So it's factorized into 8 and 10 and 2. So it's x and 10 and 2 minus and plus equals 0. So we're getting x equals 10. I'm getting the wrong. So it's supposed to be 10 and minus 2 times greater. It's greater. Huh? Yeah, man, so we get negative 20. 16 minus 32. Yeah, it's 16 or my mistake? My mistake, 16. All right, so it's what it is. It's 4 and 40. Eh? No, 16, 8 and 16 and oh, I see mistake at someone. Is that 12? Is that 12? Is that 12? 6 2 is 12. 6 2 is 12. So this is a negative 12. I cannot remember the question somewhere. Okay. Yeah, it's 20. All right, so that's at 12. Right, so I factorize this now. But 0. So x and x. It is 10 and 2 plus 1 now, minus 1 now. Cool. So here now you get an x equal negative 10. And get an x equals 2. Right? Now see the thing, you cannot just run and accept these answers by doing a log system. Logs are a peculiar kind of function. That it will give you answers that are not valid. How we know this 10 not valid? Because if you were to use a 10, I put the 10, negative 10 I mean, back in the original function here, you will be finding a log of negative 4 right there, so which you cannot find. Also, if you use it back up here, you find a log of negative 8, which cannot. So because the negative 10 cannot work in the original equation they were given to solve, this is not a valid answer. So this is the answer that you have to give. Understand that? So the logs first, and you have to check the answer them. Make sure they won't forward and find a log of something negative. You can't find log, and also to make it 0, you can't either. Log of 0 does not exist. So maybe, for example, get x equal negative 6. Can't work. You put negative 6 right there, so you get log of 0. You can't find log of 0. Sharp on the calculator, you get error. And no positive number raised to a power can be 0. It's not possible. Right? Not possible with the real numbers. Anyway, so back down here to the question that I wanted you to do. Oh, by the way, remember, look here, if you get a double angle question like this, look, get a double angle like this with a cos. Look, guys, you get a double angle with cos like that. Cos 2 theta is the most powerful double angle. I can write in 3 different ways. So we get cos double angle with cos. You're going to write this cos double angle in terms of cos squared, which is this. Cos 2 theta is 2 cos squared theta minus 1. So you're going to take this and replace it with that. So the equation would become 2 cos squared theta minus 1 minus this 3 cos theta equals 1. So you transpose and you get 2 cos squared theta minus 3 cos theta. If you over the one with this, you get minus 2 equals 0. And you factorize this. You get 2 cos theta, 2, 1 equals 0. You get in the minus here and the plus here. So you get cos theta equal negative half, cos theta equals 2. This one not valid. Because our sign cannot be outside of 1 or negative 1. So this is not valid. Cos can't be more than 1. It can't be less than negative 1 either. You'll be solving this alone, right? And to solve this now, you draw a quadrant diagram. Mark the quadrants where cos is negative. So cos is positive. Here and here, you don't want weight positive. You want weight is negative. It's negative here and there. And the principal angle for a half would be cos to the minus 1 of a half plus square angle alpha. Would be cos to the minus 1 of a half. So the alpha, I know I put the positive half, not the negative, at 60 degrees. And 60 degrees is pi by 3 in radians. And so in this quadrant, the angle is pi minus alpha. This quadrant, the answer is pi plus alpha. If you wanted this quadrant, it will be 2 pi minus alpha, but you don't want this quadrant. This angle is always just alpha, that quadrant. So the two angles for this will be theta equals, this quadrant is pi minus pi by 3, pi minus pi by 3. This quadrant is pi plus pi by 3. So then the theta will be the same as 3 over 3. 3 minus 1 is 2. So this is 2 pi by 3. Again, the same as 3 over 3. 3 1 is 4. That's 4 pi by 3. That's what it is. Now, suppose them give you instead cos, sine your test. So for example, them give you this. Look, watch this now. So what the question was, cos 2 theta, what is it? Minus 3 sine theta equals 1. No, 1 minus 2 sine squared. Did I use this? Cos 2 theta equals 1 minus 2 sine squared theta. That's what I have to use. No, so it's the, so I told them, cos 2 theta equals 2 cos squared theta minus 1. So when it's cos comes first. When it's minus, it's switch them around, but the sign comes second. All right? So you have to change this now to this. But you're trying to get something with the sign, you get me? So you use instead for this one, we change this to 1 minus 2 sine squared theta minus 3 sine theta equals 1. Then the ones will cancel each other on both sides. Take this and bring it to the side there to become positive 2 sine squared theta plus 3 sine theta will be equal to 0. You factor the sine theta and you will get 2 sine theta plus 3 equals 0. So you get sine theta equals 0 from this. You get sine theta equals minus 3 over 2 from this. Again, this is not valid. Why is not valid? Sine theta equals minus 3 over 2 over the y. And a 1.5 that. A 1.5. So this is not valid. Sine or cos cannot be outside of negative 1 and 1. Sine and cos can only go between negative 1 and 1. Just like the graph, go to 1 and go down to negative 1. Sine and cos of any angle can go over 1, can go below negative 1. So like this, do have the answer. Can't get me. If you try to find sine to minus 1 of this, I get an error message. Remember, sine and cos are fractions of the hypotenuse and opposite of hypotenuse. You remember? Opposite chart and hypotenuse are equal to the hypotenuse, right? So it can't be more than 1. It can't be less than negative 1. So this would give you now, this one will give you now 0, pi, and 2 pi. 0, pi, and 2 pi. When sine equals 0, you get 0, pi, and 2 pi. 0, pi, and 2 pi, you so theta will be 0, pi, and 2 pi. Because sine of each of them equals 0. 0, pi, and 2. Alright, so that would be. But anyway, same final question I showed more, show still. CJ, watch this now, guys. Watch it. Everybody pay attention. Everybody pay attention. Because this pop up an example for you. And then you can shut it off. But what I say that they give you 2 points on the end point of a diameter of a circle. I'm on the equation of the circle. So you might think you will find the midpoint to get the center. And then find the distance from the midpoint to the circumference, right? You don't have to do that. Pay attention. Right? When they give you the endpoints of a diameter of a circle, you want to get the equation. You cannot do this. Watch. Let me sketch it out and show you. So if I have a circle like that, I'm going to have 1, 0. So this is 1, 0. And say across on the diameter over here, so you have the point 3, 2. So this is the diameter, right? What we know about a diameter? A diameter subtends 90 degrees at the circumference. Know that, don't it? So if this point up here so represents all points on the circumference, then it can have coordinates x, y. All this point P, x, y, representing all points on the circumference. If we can establish a formula connecting x and the y, then we would have the equation of that circle. But x, y basically represent coordinates of points on the circumference. So any point on the circumference you're drawing from these diameter, it's gonna be such that right is 90 degrees. But diameter subtends 90 degrees, right? It means that the line here perpendicular to the line here at all times. That's all. What do you know about perpendicular line? Product of the gradient is -1. So let's say we call this point down as A. Call this point over as a B. It means that AP is perpendicular to BP. Don't it? No matter where the point P is. AP is perpendicular to BP, right? So it means that the gradient of AP times the gradient of BP is -1. That's all. That's what you give it the equation and set it up. What will be the gradient of AP in these 2 points? The difference in the y value is y minus 0. Difference in the y value is, which is y minus 0 over difference in x values, x minus 1 times what will be the gradient of this one? Y minus 2 over x minus 3. That's equal to -1. When we expand that out and see it becomes the equation of a circle. So I'm going to take these two that are multiplying each other, multiply by the -1 over there. So over here, I'm going to be left with y times y minus 2 equals -1 into x minus 1 times x minus 3. Expand this, I get y squared minus 2y equals, expand this, I get minus bracket x squared minus 4x plus 3. See that? Y squared minus 2y equals minus x squared plus 4x minus 3. Transpose everything. I get y squared plus x squared. Yeah, so I get plus x squared. So what it may get? Wait, I'm gonna put x squared first. I'm gonna put x squared first. So cancel over first, I get x squared plus y squared. Here what is, I get minus 4x minus 2y. Here what is 3, I get plus 3 equals 0. That is the equation of the circle. I'm gonna have to find a midpoint. And you want to work it the other way, I get the same equation. Right? But this is a nice way to do it if you have the diameter at the end point. Just get an expression for here, call the point P, X, Y, the then expression for the gradients, 2 gradients, multiply them, multiply quantitative one, and simplify. A question like this can't come on your exam paper. Can't come on your exam. And a lot of people that just find the midpoint first by taking the midpoint between these two here as the center point. And find the length of the radius is the distance formula, and that will be the radius. So a lot of people do it that way, but this way to me, easier. This way easier. Yeah. We don't have time to look at it. To my exam. Because at point I'm stop it up. That point I'm doing so I hold your class. That is it though, by support. I wanna take exam. Don't I take exam? You wanna take exam tomorrow? I wanna have time still. Okay. We have time to do the multiple choice. Multiple choice allows you to touch on some topics, guys, or you don't say a lot. I said, we come tonight. You want to touch those multiple choice that I said. All right, guys. So, where are the next thing? We're going down to model 3. Model 3 with the differentiation and so on, integration. You want to motion and straight line. All right. Motion and straight line part with the so let's do that. So let me go back to the 2025, 2024. We're working on the most recent exam paper, right? 2024, 2025. So let me go back. You can come up with this now, please. Come and move. All right. All right. So we're going back for the 2024, 2025 papers. These. So these you want to do. All right, no problem. So some revision, right? So listen, you have this thing to do. You are right, this is a power function. Integrating a power function. There are no limits, so don't forget your C, guys. So this becomes equal to 2x plus 1 to the half that you're integrating with respect to x. All right, so you're going to add 1 to the power, add 1 to this. So you're right by the same thing, which is 2x plus 1 to the power 3 over 2. I add 1 to the power. Divide by the 3 over 2. Remember also to divide by the differential what's inside here. It's 2. So divide also by 2. And don't forget the C. Right? So let me show you something before we move on. Show you something before we move on. Right? So this will simplify, because this 2 cancels this 2. So it will simplify into so this under here so means square root. This 3 on top here so means power. So if you write it back at the gave you, they become 1 over 3. But a 2 I cancel that 2, leave it at 1 over 3 there. I'm gonna get the square root because that is 2 under here. Of, huh? You have to divide by the differential of what's in the bracket, which is 2. When you differentiate, you have to multiply by the differential of what's in the bracket. When you integrate, you have to divide by the differential of what's in the bracket as well. See it? Let me show you something. So you get 2x plus 1 cubed plus c. That's it, right? Well, let me show you something before we move. Watch this now. Let me show you something right here. So. Quick and fast. Suppose I get this to integrate, right? So we get this to integrate. Watch it, pay attention. So we get this to integrate. The integral, so we get this. The integral of 3x plus, so 3x plus 1 squared dx. Right? 3x plus 1 squared dx. No problem. You can integrate this straight. Becomes equal to, add 1 to the power. You're going to get 3x plus 1. Add 1 to the power. Let me change this stuff. Let me change this to 2. Divide by the new power. Change this to 2. And divide by the 2 as well. Divide by the differential of this 2 as well. So you get plus 1, eh? Plus c. Good? So your record to be 2x plus 1 cube over 6 plus c, eh? So it's okay to divide by the differential of what's in here. Divide by that 2. Good? Watch this now. Suppose instead, does this. A different color. Black. All right. Suppose instead it was the integral of 2x squared plus 1 r squared dx. Yeah, that's it. Change do that shortcut, like how just there some divide by the 2 on here. So when I differentiate this, now I get 4x. Can't divide by anything with an x in it. When you integrate it, you have to expand. So you couldn't do shortcut. So if you go to 2 of them, look at them. Key difference is that when we differentiate this, we're going to get in 2. We differentiate this, we get in 4x. Anything with an expand it, you can't divide it. So you can't use a shortcut when the differential of what's in the bracket. Not just going to give that constant. So you have to expand. So for this one, you have to expand it out into separate terms. All right, this term squared, which will be 4x to the 4th power. 4 squared over 2 will be plus 4x squared. Second term is going to be 1 dx. That is why you have to integrate. So you have to expand it. So you say, we have the same power 2, you know. I can shortcut that one. Never have to expand it. I have to expand on that one. Why? Because the differential of what's in the bracket by x and you can divide by new lines when you integrate it. Cool? You can divide by a differential of this when it's just a 2. Shortcut. When I have to expand that one here. Yeah, shortcut that one. You can't shortcut this. Huh? Finish this? Yeah, just integrate term by term now. I left it up. The hard part already. Add 1 to the power 4x to the 5th power over 5, 4x cubed over 3 plus x plus c. That's it. But you can shortcut this one because the differential of what's in the bracket is a constant value you cannot divide by. You can shortcut out because the differential of what's in the bracket is actually a function of x, 4x. You can divide by 4x. You cannot divide by a constant. When you differentiate, you can multiply by anything. You know? When you integrate, you can't divide by anything. You only divide by a constant. All right? So, yeah, because it never come true when you divide. It never come true. It doesn't become true when you divide. But then integrating quotients is a topic by itself. But depending on the type of quotient that you're integrating, the methodology and the approach is different. So integrating fractional functions, is a topic in itself. So within integration, it becomes a integrating quotient is a topic by itself. All different types, or the method they use depend on. Some of them have to introduce tricks in them. Some of them have to use tan, some of them use sine, different things, different approach have to use. Some of them becomes log function, like element, different things. So the method that you use depends on what you're seeing in front of you. The approach becomes different. All right, but let's continue. But this one now, integrating tricks. Now, when integrating tricks, I don't get no higher than sign and pass. Most of the will do is give you a multiple on the sign here, so. Which you have to remember, you have to also divide by the differential. When you integrate. So all you have to do, don't give it away again. Just remember, when you differentiate sign, you just get cos. So when you integrate cos, you just get back sign. When you differentiate cos though, you get a minus sign. So if you integrate sine, you must get back minus cos. Get me? See here. I have to remember this. Differentiate sine, you get cos. So therefore, you integrate cos, you get them back sine. You differentiate cos, you get minus sine. So when you integrate sine, get them back minus cos. All right. So when I'm integrating sine and cos, I always remember what I differentiate first. All right. I always remind myself what I differentiate. All right. So this one becomes equal to. When you differentiate sine, you get cos. So therefore, if you integrate cos, you just want to have sine. A negative sign change don't come into that one. When you differentiate cos, you get negative sine. So therefore, if you integrate sine, you're going to get negative cos. See, there's a sign change down here. There's no sign change up here. Cool? Cool. So in this example, we have sine to integrate. Right? So if you want, you can write down them on the paper and you can remember. Right? So here now, I have sine to integrate. So I'm thinking to myself, when I differentiate cos, I get minus sine. So I'm integrate sine, we're going to get minus cos. So it's going to come out to be a negative value. So I get minus cos 2x. I have to also divide by the differential of the 2x, which is 2. We divide by the 2. Then when we differentiate sine, I get cos. So when I integrate the cos, I just get back sine. So I just get back plus 5 sine x. Don't forget the c. Don't forget to add the plus c, because we don't have any limits integrated. Don't forget the c. That's it. All right? Simple as that. One you say, show the enclosed area by this curve and that line. And I wanted to find the area. I'm not going to do this. Area to the integral of y dx. Area of this region is the integral of the equation of a curve dx between 0 and 3. Now let's do it. Area under the curve. Area under the curve is the integral of y dx. In this case, is 0 and 3. So the integral of the equation of a curve with respect to x between the limits of x value. Between x, we're not getting none higher than this. Syllabus there, we're not even supposed to get no compound shapes. This is what the syllabus says. So the syllabus says, shape integration is supposed to get. Right? So this becomes equal to integral from 0 to 3. What the equation of this curve? This curve is x squared plus 2. X squared plus 2. So A equals x cubed over 3 plus 2x between 3 and 0. So let's plug in those values now and verify itself out. So A equals, plug in the 3 first, we get 3 cubed over 3 plus 2 times 3, the first bracket, subtract, you plug in the 0 here, and they're going to get 0. So subtracting 0. This works out to what? This is 3 on the yes and not 2, 3. 27 3 is 9. 9 and 6 are 12, right? 9 and 6 are 15. That's 6. 15. Hello? No. That's 15 units squared. I don't know. What's that time? Yeah. All right. 15 units squared. So that good. So this one now asking you for volume. Right? So it says show the region again of that curve. And it says the region rotated about the x-axis, one complete where you get the volume of the solid form. Volume is pi times the integral of y squared dx. I'm going between 0 and 2. Right? Between 0 and 2. Between 0 and 2. So one have to square this function, this. And see, because they have a square on it, we have to expand. Can't short, right? So it becomes equal to I times the integral from 0 to 2, 4 minus x squared dx. Y squared. Remember the y is this, you know? So I have to square it in the sum. You have to expand this. I can't divide by 2x. See that? So it becomes pi times the integral. Square this first, we get 16. Quadric over 2 is minus 8x squared. Second term is plus x to the 4th power dx between 0 and 2. So that volume comes pi into 16x minus 8x cubed over 3 plus x to the 5th power over 5 between 2 and 0. If plug in the 2 now, v equals pi into, plug in the 2 first, 16 times 2 minus 8 times 2 cubed over 3 plus 2 to the 5th power over 5. The first bracket subtract. If plug in the 0, everywhere over here is 0. So let's subtract 0 now. Minus 0. Where that out, I can leave the answer in terms of the pi. So V equals whatever that is, pi units, whatever that value is, pi units cube, volume is units cube. Volume is units cube. Huh? Volume is units cube. I need a volume now, you 256 over 256 over 15. 256 over 15. Pi units cube. How about this question now? thing that on it. People have motion and straight line on it. That's saying I have none. Lie. That's saying I have no motion and straight line at all. Ridiculous. What? I said no motion. I didn't realize enough. No motion and straight line last year. This is really going on weird. 2024. You have a question what you want me to do? On the motion and straight line in particular one? All right, so number 4 here. And a number 4 and number 5. All right, let's go. 2025, we just go over. Huh? I would just go 2024. Oh, you want 2018? I will do that one. You want 2018? You see the motion and straight line on this one. All right, so motion and straight line here. Do this one. So remember for this topic, guys, if the acceleration is constant, you can use the equations of motion that they give you on the formula sheet. V equals U plus AT. V squared equals U squared plus 2AS. S equals UT plus half AT squared. There are two other that are very good. S equals average velocity, U plus V times time. And another one is S equals VT minus half AT squared. That is when the A constant, when A is constant. Can use the formula for the equations of V is velocity, use initial velocity, T is time, S is displacement. That's it. Right? The formula there can be used for any period the acceleration is constant. Those are the equations of motion. For any period the acceleration is a constant body. All right? So those can be used. These are the three that put on the formula sheet. These two are pretty good, depending on what you have. Right? With those, you can find anything. You can find anything, any annual. So any three thing you know, you can find a fourth thing. All of them formula connects 4 things. But any 3 things you know, you can find a 4th thing. Right? But when the acceleration is not constant, you're going to have to use calculus. You have to use differentiation and integration. And what is it? It is this. When you have displacement, you differentiate displacement. You get velocity. Differentiate velocity to get acceleration. Right? If you have acceleration, you're going to have to integrate now to get back the velocity. Integrate the acceleration to get back velocity. You're going to opposite the way, you know, reversing the process. And if you have velocity, you have to integrate to get displacement. That is it in a nutshell. Right? Remember, when you integrate, you have to introduce a constant of integration. Introduce a constant of integration. That will give you information for you to know what a constant of integration is when you integrate. Huh? If you get velocity, I get limits. If you get velocity over time graph, remember that gradient on a velocity time graph is acceleration. Area under the graph is displacement or distance traveled in an interval. Right? When the graph goes below the x-axis, it means that you're going in the opposite direction. That's an velocity time graph. And same thing with displacement. When you go below the x-axis, it means that you're going in the opposite direction from the reference point. Remember, displacement graph shows distance from a reference point. It's not meant to show distance travel, show where you are from a reference point. All right? Those are some of the main things we spoke about in class. All right, let's go. So this question now says, as a particle moving in a straight line, its displacement is measured from a fixed point O on the line. At time t seconds, the acceleration is this. So they give you the acceleration. So you have to integrate to get velocity. It says, find an expression for velocity v of the particle, given that when t equals 1, the v equals 3. That is for you to find your c, your constant when you integrate. Right? So the v that you want, I can set up this way, dv by dt. Because that's what acceleration is enough, dv by dt. So the a is dv by dt, rate of change velocity, and it is equal to 24t minus 4t. So you're solving that. So it means that dv is equal to 24t minus 14 dt. So you're going to have to integrate both sides now. Integrate this side and integrate that side. Now watch this now, guys. You can actually do this without actually calculating a c or working out a c first. You can work out the c intrinsically in the expression by putting the limits on the integral like this. So the values that they give you here, t and v that they give you, put them down on the starting of the integral. So that's this is the t side, this is the v side. So I'm starting at t down here at 1, and when t is 1, the v is 3. The v is 3. This I'm going up to a general point, a general time t. And here I'm going up to a general speed v. And I don't need to put no constant. If you want, you can get a constant and then use these values to find a constant, fine. But I'm telling you, you can actually do it this way by putting limits on it, so you don't put no constant. You just get the equation straight. The equation. So you put the values that you will use to find a constant down here, and then you since you integrate with respect to t, you put t up here, so with respect to v, you put v up here, so. And then this dv is really 1 dv. It's really 1 dv. 1 dv. So like you're integrating 1 with respect to v. See that? So we integrate this side. When you integrate 1 with respect to v, it becomes v between v and 3. Equal. Integrate inside here, so no. You're gonna get add 1 to the power divided by the new power. It's gonna become 12t squared. Everybody say that? It's gonna become 12t squared integrated. Everybody say that? Right? You're going to divide by the 2, right? And this is going to become minus 14t. And you're going between t and 1. So you plug in the v upon the v. And then subtract, plug in the 3 upon the v. So this side becomes v minus 3. Equal. You plug in the t upon the same thing. So you get about the same thing. 12t squared minus 14t. Subtract, plug in the 1. Plug in the 1. You plug in 1, that's say I get 12. You plug in 1, that's say I get 14. So you see the C work out itself in there. I do that way. But if you're working it out first, you get this equal this. And you have a plus C. When you plug in the 1 and the T, you get them expressions there anyway. You understand? Good. So you work out itself when you do that method I'm going to show you guys. And then you do less work. So this over here says one. This over here is actually this is what negative 2. So all this becomes a positive 2 in the end, don't it? And a 5, so you go back add to the 2, give me 5, right? Get 5 over there. So you end up get v equals 12t squared minus 14t plus 5. What I wanted, an expression for velocity. This is it. That's the answer. That's my expression for velocity. See that? That's my expression for velocity. All right. If you want to integrate with all the limits, put a C and then use a T and a 3, find the C, fine. But I'm telling you guys, you can get it this way without having to work out the C separately. You get the equation straight up. Right? For the expression for the velocity. Then down here now say use your answer in part B to find an expression for the displacement of the particle, given that T equals 1, S equals 10. So again, we're going to integrate again now. So we're going to integrate the velocity now. So this is the velocity right here. We're integrate the velocity to get displacement, right? So see here now, watch this now. The displacement, the velocity is the rate of change of the displacement. That's what the velocity is. So the velocity is ds by dt. So ds by dt is now equal to this thing that we have up here, so, which is 12t squared minus 14t plus 5. So the same thing again, we have to integrate both sides. So that we work from right to this. So watch this again. So ds becomes 12t squared minus 14t plus 5 and multiply the dt over there. So you get dt. What you do now, you integrate both sides. See that? Integrate both sides again. Integrate that side, integrate that side. Same thing again, we're not finding C. Put these values down on the lower limit. So you put the distance down here, so make it 10 at the displacement. Put the time down on here, so make it 1. And then up here, so you put T, up here, so you put S. And that way there now, remember, so integrating ds is similar like you integrate 1 ds. So this side becomes S between 10 and S equals, so what you have to know? Yes, I get 60, no, not 60, I get 3, right? I get 1, 3 on the S, so I get 40 cube, right? 40 cube yes, I get 70 squared plus 5t between t and 1. So that's how I become now S minus 10 equal to this small. That's why space is really limited. This is really limited. Right. So it's talking me S minus 10, and plug in the S and then plug in the 10 and subtract it. Equals. Plug in the T first to get back everything the same, right? So I get 4t cubed minus 7t squared plus 5t. Subtract now, and plug in the 1. You plug in 1 here, so I get 4. Plug in 1 here, so I get minus 7. Plug in 1 here, so I get plus 5. So I get S equals 4t cubed minus 7t squared plus 5t. What's our report now? I must have 10, I go back and add to that 10. What is the report first? So 7 minus, that's negative 3 plus 5. I can say, you can say 9 minus 7 is 2, right? So negative 2, and then 10 go over and add to it. 10 minus 2 is 8. 8. So I get plus 8. Plus 8. That's the expression for the displacement. Yeah, it's a become a 2. So I make it negative 2. This I make it negative 2. I make it over the 10. Right, so 10 minus 2 is 8. So I say again, I say, when I tell you, say, about space so limited, and then we'll calculate C on a different line. You get me? Let's do it that way here. And done. Done. This part now said the grade of a function is this. Everybody know for this, right? So dy by dx them give. So this I same thing this now, you know. So dy by dx. dy by dx is 7 minus 2x. Right? It means that dy is equal to 7 minus 2x dx. And say integrate both sides. Integrate that side here and integrate that side here. Same thing. It's that point. So the x value come down here, so y value come down here, so x go up here, so and y go up here, so. So we don't know if we calculate the c. So this becomes 3 under here, so and 8 up here, so. That gives you the equation straight by integrating 1 dy. So that becomes y between y and 8 equals, yes or no, 7x minus x squared between x and 3. So this becomes y minus 8 equals 7x minus x squared minus plug in the 3 now. I get 7 3's first is 21 minus 3 squared, right? This is 9. See that? 21 minus 9 is how much? Then like 20 minus 8, won't it? 21 minus 9 is what? Minus 12. I don't minus about 12. The 21 minus 9. Huh? 11, 12. 12, right? So the negative 12 I get, right? Then the 8 I come over to my plus 8. Negative 12 and 8 is negative 4, right? Oh, negative 4. So I have with negative 4 there. So this equation becomes y equals 7x minus x squared minus 4. It's 2024. You say one, 2018, right? 2018. Let me see. 2018. Which question, man? I'm gone. You want to discuss them, but it's not a syllabus, man. You send me this morning. No, you send me this question. Yeah? Yeah. But it's not a syllabus anymore. Function. Because this just wanted the inverse. Inverse is the reflected line where I call x. So you're going to draw a line where I call x to here, so for example. No, not this, so Mr. Shaw. Here's some. 5, 5, 6, 6. That'll be right here. Alright, so minus 5 minus 5 is here. So you draw one straight line through here, so. So now y called x will draw. Right? And reflecting that one. To get the inverse. But it's not a syllabus anymore. So watch me now. So this point which is at 0, 4, it's coming 0 negative 4 is coming to negative 4, 0 here. So this point which is at 1 negative 3 is coming to negative 3, 1. The coordinate switch around. This point which is 2, 0 is coming to 0, 2. Here so. This point which is at 3, 5 is coming to 5, 3 right here. So it's like a reflector across here. So in this point, the function inverse pass through the same point on the y-axis. And the line y equals x. See? So let's draw the inverse like this. Something like that will be an inverse. Draw it. See? That will be an inverse. F to the minus 1 of x. See that? So it's reflecting line y equals x. And you have the inverse. So you look like a reflection. The red line like a line of symmetry. It's line y equals x. And to ask the relationship, that's it. The reflection line y equals x. That's the relationship between a function and inverse. They are reflections of each other in the line y equals x. Which question you want on this number, boss? You ask about a question, don't you? You, Dominic. You ask about a question here, and then give the three roots them. See there, they give the three roots. And these are the three factors. For this root, x minus 1. And let's expand them here. Let's multiply them and expand them. That's it. See, they give the three roots. So you have the three factors. X minus 1, x minus 2, x plus 4. And then let's multiply them and expand them and write them in descending powers. So very easy. We don't bother with it. Which question you say you want? On this paper? 28 in this. Which question on it you want? Huh? Question 2? This one? Solution is not the no. Cuando nace todo, alfa, beta, un pasito, alfa, beta, ¿eh? ¿Eso? You want all a question 2. All right. All right. Yeah, man, this still on the syllabus. Complete in the square. So this question, give me that function, right, in the form of this. So we're going to complete the square, right? So what we're going to do is factorize out the minus out of these two terms. When you factorize with a negative, you have to be careful. You have to be careful and change the sign of this one as well, right? So if we have g of x, it's minus x squared plus x minus 3. We have factorized minus 1 out of those two terms. So we got minus 1 into x squared minus x minus 3. See that? So it becomes minus 1 into x, half of the coefficient here. Now the coefficient here is 1. So you get minus half squared minus the square of this is 1/4. And then subtract by this short. Same thing we do again. Half the coefficient here, so subtract the square of this. The only key step right is when you factorize the negative from that, you have to change the sign on this one as well. It's a key thing, right? All right. So this color will opening it up now. So you get minus bracket x minus a half squared is minus minus, it makes a plus quarter minus 3. 3 the same as 12/4, don't it? So it becomes minus x minus half squared minus 12/1 is minus 11/4. That is it. Them say, on the grid, provide below, sketch of the function showing the maximum point and the y-intercept. So based on this, the maximum point is gonna have this as its y value, don't it? And the x value is when this equals 0. Good? Remember, it is when this equals 0. That's when the g of x equals the negative that, right? So when this inside equals 0, x equals half. So it's a half. So that the maximum point. Only the maximum, but the square term is negative, right? And the y-intercept corresponds to the c value. So the y-intercept is 0c, which is going to be 0, -3. Right? So what do we have? We have half, -11, and I say -11 and thing there as well, in terms of a mixed number. Is half, -2 and 3/4, don't it? I don't give me a scale, I kind of want to make it accurate, right? I then put scale upon the graph. So -2 and 3/4, that's all. Good. So half is right here. That's half. I mean -2 and 3/4. And let's look at this is 1 unit. So this is -2.5. 2 and 3/4, therefore is gonna be halfway between here and here, don't it? So it's a -2.5, you know. So -2 and 3/4 about right so there, don't it? So that's gonna be my maximum turning point. So I'm gonna use that as my maximum point right here. It's my maximum point, half, -2 and 3/4. It passed through -3 on the y-axis. Pass through -3 on the y-axis, don't it? That's right here, so. Now, yeah, it going to turn us now gamma roots. Now reach x-axis. Right? Now reach x-axis. Now gamma real roots. Now, this graph is symmetrical. So, like what is reach 3 on this because it have a line of axis of symmetry here. So the value is going to be the same distance. Right? Same distance. So we need to get some values. So gotta give me a grid, one kind of get an accurate graph. So this point, this guy don't be a point on it. See that? So to the good to know what this point is as well. So we can get another corresponding point over here. Them two will give the same, but the same distance from this axis of symmetry. So whatever y value we get for this, we're gonna get the same y value here. So see that? Because the graph is symmetrical. All right. So let's see what we get for the 2. Let's see what the 2 gives us. So x equals 2. Y equals, what is it again? Minus, there is a factor formula of this one. So I use minus bracket, 2 minus a half squared, minus 11/4. Where that out from? Remember the y is equal to minus x minus half squared, minus 11/4. So tell me what I get from the 2 or so. What I get? So I can get at least one more value on this line and on this line. What I get? What is it for me now? If I wrote it to myself, you working out, Jordan? Huh? -5 exact? -5. -5. So this one going to give a -5 because the same distance. So now we waste that. So it's going to pass through here. So same distance from this, the same distance from this. Going to be -5 also around here. Right? So draw the curve through those. That's good enough, I think. And it's a one report for this one as well. It should be 2.5. Don't report to 2.5, so it goes up. Let's draw the curve through this. So then it's going to go like so. And then so. Something like that. So that's a bit of curve. Something like that. Alright, that is and that done that part, right? Let's just sketch a graph. This one now says geometric series, a geometric progression and a third term of 25. That means that AR squared is 25. It's a GP. So when you get GP, when you get simultaneous equation from a GP, you tend to divide it and substitute. Is that the same like the question we did earlier? Same thing. First and the second term at 150. A plus AR equals what? I don't know about this, don't it? And again, them say R greater than 0. Huh? We don't have to do this again, man. I waste time. Divide them. We don't question that earlier. Say, almost easy enough. Actually, repeat the question. What they did earlier, they give us 50 and give it 200 or so. I see a question. Because I did earlier, must 2024. Then give it 50 or so and give it 200 or so. 50, them say, and 200. That was it. And they asked for what? That one asked for the ratio. What this one asked for? This one said, determine the sum of the first 4 terms. That's the one difference. No, this one wanted the sum of the first 4 terms. The one that we did earlier, only wanted the common ratio. This one wanted the sum of the first 4 terms. All right, so let's find, if we can find the R, we can multiply this by the R, that's a 4th term, don't it? And then we'll just add up all of them and we have the sum of the 4 terms. All right, so we're going to divide them again. Let's divide. We're going to divide. We'll divide. We're going to get AR squared over A plus AR equals 25 over 150. What is it? What is the report? 25 over 150. Huh? It almost look the same. No, not the exact same distance. This is 2018. The one on the first 4. The same word. The other one wanted the R alone. And it's 2024. It's a 2018. And I think the one we did earlier, this was 200 and this was 50. And I wanted the R alone. What's your report? What are we share report to? 1/6. So 1 pair and the 8 cancel again, right? So the 8 cancel. Let's give me 1 right there, so the 8 cancel, right? And so multiply the 6 up top here. We're gonna get 6R squared multiplied by 1 plus R. There's a 1 plus R over this. Over here, so equal 1 plus R. So you transpose, you're gonna get 6R squared minus R minus 1 equals 0. Factorize this. We're gonna get 3R, 2R, 1 and 1. Afterwards, 6 and opposite again, minus and plus. Yeah, that's right. So then get R equals minus a third, R equals half. This one is not valid. Because they tell us that the R is greater than 1, right? So if the R is equal to a half, and it's at the 3rd term, it means that the 4th term is just multiplied by the 4th term, don't it? By R, don't it? So the sum of the first 4 terms are them 2 here plus this plus the 4th term, don't it? And the 4th term is just half times that, right? So now for the A now. Right? So see here now, sum to 4 terms. Sum to 4 terms. Equal the first term plus the second term plus the 3rd term plus the 4th term. And this is just the 1 times R, right? That's all. So them 2 here are 150. See that? It's a 150. It's a 25. And I want a 25 times half. See that? Put that in the calculator and you're done. The 4th term is 25 times the R. Huh? Can't be 118 mile. 187.5. I still had 150 and 175 that already, you know. All right. 187.5. You want to say, you want to discuss that? Discuss that. You want to discuss that too? All right. So we have that equation there. And I want to find this. You want this in terms of alpha plus beta and alpha beta. That's what you want. So you need to know these two values. All right? Because the equation of those two rules. So the first thing you want is the alpha plus beta, which is minus b over a, which then becomes minus negative 5 over 2, which is 5 over 2. Or if you want, you could put 2.5. Then alpha beta is c over a, which then is 3 over 2. Or if you want, you can put 1.5. Now, you want 1 over alpha squared plus 1 over beta squared. That becomes equal to, it becomes alpha squared plus beta squared over alpha beta r squared. You can see that? Got it. And then the alpha squared plus beta squared on top is alpha plus beta r squared minus 2 alpha beta all over alpha beta r squared. So, and drop in the values on this. So it becomes alpha plus beta is 2.5 and you square it minus 2 times alpha beta is 2 times 1.5 divided by 1.5 squared. Put all that in the calculator and tell me again. Yeah, and I confidence in that, and you can't do the question, you know. So we have movies, we have memory. We know if you do it. Yes, I know it yourself. You know if you do it, man. But take a break off of it. Dominica sleep there. And you, Dominica sleep and you not pay attention. No boss. But take a look at half an hour break. What time is it now? But take a break till 5 o'clock and we start back. And we'll go on and we take the half an hour and decide what we want to do. 4.0? 4.9? This is supposed to give me an exact value now, boss. Them numbers are supposed to get an exact value for the answers. It's supposed to give me an exact one. 4.9 exact? Huh? Let me see me get 2.5 squared minus 3. Got a 2 times 2.5 is that 3 that. Minus 2 times 2 times 1.5 is 3 over 1.5 squared. 0.5 squared. You know what you get to get 13 over 9. Huh? 13 over 9 again? Yeah, 13 over 9. Anyway, another question on this you wanted to do? It's another circle question there. Same thing, greatest and center again. Huh? Dominic, I take a half an hour break, guys. I take a half an hour break. Right? And I'll look through one more time. Pick out the question them on, we'll come back with a one last push. See? So look through the whole paper them, especially the recent ones, and decide which question I want me to do again. One last time, one last push. All right? One last push. So look through and see which question I want me to explain. You don't have to know where no one help. You have your own brain. You must know where you want help. I'm afraid to put on the time on them. I put on and just remember to take it down back. So I put on the time on this. All right. I'm gonna have full half an hour, you know. I may also need to charge the device. That's another thing. To charge the device. Still keep going. Keep doing this thing. I'm going to have full 30 minutes breaks. Giving you time to look through and tell me what you want to do. 30 minutes. All right? So you can look through, tell me what you want to look at. Huh? Let me hear the man myself. So I'm gonna look through and tell me. You know, on the random thing. Want the specific. You know, to find the specific question them know. That's where we're at. So look through the thing them and I teach them from scratch now, like a lesson. And it's just a question, because don't teach everything already, just particular questions that you want to look at now. Because you know, teach a lesson now, like from scratch. Not just particular questions. Anything I question, I understand. But don't teach everything from scratch already. All them questions I do already, you know. All these questions I'm doing now, I've done them already in class. All right? We're starting back at about 5 o'clock. Tell me the particular question what you want to do after the break. Don't just not in a topic. I teach a topic. Don't teach teacher. I'm going to drop question. I'm fine. 1 minute. So time plan. Having fun. Uh, 1 minute. Check. 1 minute. It's time, gentlemen. It's time. I guess. Are you ready to go? Props. The props. I'm gonna do a couple. I'm gonna do a couple. Section 2 questions. There's a question on 2023 that I was looking at a while ago that I would want to go through quickly. He sent me a question. I want to hear a question first. He sent me a statistics question. I just paper it on again, 20. Old paper, 2025 or something. Which one? 2018. Then I could do earlier. 2018 on the screen here. I'm gonna see people online can still see the screen. Christiana Buchanan can still see the screen. But I guess I can see it. All right. All right, so you say what? 2018 what? Huh? 4C? 4C. 4C. This one is proof. The proof. Let's talk about this. All right, watch this thing. So for this proof, key thing here is that they have two fractions and make it into one. All right? So you're not gonna add them. But there are some telltale signs on somebody's identity that you should know. So for example, when you see the 1 minus sign and the 1 minus and the 1 plus sign, they come from this. Remember, cos squared x is 1 minus sine squared x, which is same as 1 minus sine x times 1 plus sine x. So them two here, I give you about this sum here, sum. Get me? It also goes the other way with the sine. Because sine squared x, as you know, is 1 minus cos squared x, which can be written as 1 minus cos x times 1 plus cos x. So every time it's a 1 minus sine, 1 minus cos and 1 plus cos, you should be thinking about sine squared somewhere. You put them together, they become that. Get me? So once you see those, you know that. All right. So let me show you a little method now. Show you something. Let me show you something. So let's say they give you this to prove, right? And you can't see right off the bat where you're gonna go from this to this, right? You're not seeing it. What you can do is start work from this roughly and work back towards this. No, you're not using the right hand side to get it. I'm saying you want to see, it's like you're bringing the two sides towards each other in a sense, roughly. So you want to see what this is back towards here and what this is back towards it. It's like you're trying to find a middle ground between them. When you find that middle ground, all you have to do now, is bring this to the middle ground and then carry it all the way. You understand me? So sometimes you want to just simplify this a little bit or rewrite it back a little bit and kind of bring it closer to the side there. And then now you say, okay, once you can carry this to that point that you have identified, then you can go the rest of the way. If you can't see it right after it. So what is that thing I would do with this? I don't like when the sine, cos, and tan mix up together. I like to keep the sine and cos together or tan by itself. So I would say this, if I want to carry this back a part way here, so I change that tan here to sine over cos. And it would have become 2 sine x over this cos x is under here already. Cos x. And then the tan over sine, the tan is sine x over cos x. So we write the tan as sine x over cos x right there. So see that? Now this becomes 2 sine x over cos squared x. Over cos squared x. See that? So it means that if we can bring this down to here, so then we can finish the way up to there. So you get what I say? And it is and I know see something familiar. I know see something familiar because I know that these two are factors of cos squared. You get me? So I'm basically saying way through. Right? I'm basically saying way through. So all I'm gonna do is add these two together. So this is like a little rough work, you know, I present this to the examiner, you know. It's a little rough private work. You know, I show that that's part of the solution. Just help yourself. If you can't see how you're gonna go from this to this all the way. Just carry this back this way a little bit until you reach a point where you know you can carry this too. You get me? I help yourself. All right. So when I work this out now, when I say the left side becomes I'm adding these two fractions. So to add those two, let me write it out. Let me write it out. 1 minus sine x minus 1 over 1 plus sine x, right? I'll move this out of the way. So that's all like a rough work to see, you know, that this thing really take you to there. So how do I add these two fractions now? You can do LCM if you want, but a nice way to do it is to actually I'm gonna write it over. A nice way to do it is to actually multiply this fraction with this denominator up here and down there. And then multiply this fraction up here and down here with this denominator. So the two denominators become the same. So I'm going to multiply this one up here and down here. So I'm multiplying by 1 plus sine x over 1 plus sine x. And then this one I'm multiplying 1 minus sine x over 1 minus sine x. So I've taken this denominator, multiplied up here and down here. And I've taken this denominator, multiplied up here and down here. So that way the two denominators are going to become the same. You see that? So you could use LCM method as well, same difference. So this then becomes, this numerator becomes 1 plus sine x minus this numerator. See, it's minus, you know, so if I put minus, and I put in a bracket, 1 minus sine x over this times this in both cases. 1 minus sine x times 1 plus sine x. Right? So the numerator becomes 2 sine x. See that? The numerator becomes 2 sine x. Because the 1 cancel the 1 there. And it's minus makes it a plus sine x. So I get 2 sine x. Sine x plus sine x is 2 sine x up here. So I get 2 sine x on top of, now this under here, so it's 1 minus sine squared x, which is cos squared x, right? See that? So I've reached this halfway mark. So I'm good to go now. So all I have to do now is split that cos squared x here and put the sin x over one of them. So I'm going to write 2 sin x over split that cos squared there and write it as cos x times cos x. And then this sin x over cos x is tan x. Right? So it becomes 2 tan x over this cos x right here, which is the right hand side. And that is it. All right. So when you can't see the full way through, just roll the right side back closer to the left side a little bit. Just kind of bring it back close. Just find a middle point. You roll the left side back to that middle point, and you'll be able to go all the way after that. So something you kind of help yourself in a sense. All right. Very good. All right. So I think they give me what 2015. I think a 2015 question 8 or something like that in that section. There's a question in 2023 that I want to touch on because it had us drawing a graph, velocity and graph. So I just want to touch on a question and then we'll go to the section. Right? So let me see if we can find it. 2023. Oh. (2023). The question, I think we touched on it. Some of us touched on it yesterday, right here. This one. Remember this, Jordan? We touched on this yesterday. So this question gave us this function. Very easy question. And it told us, you did it yesterday, right? It told us that the gradient is this. So that basically giving us the dy by dx. And it told us that the stationary value is 5. The stationary value is a y value at the stationary point. That's what the stationary value is. The y value at the stationary point. Right? So they want us to find a, b, and c. But that's the function. And this basically is your dy by dx. Right? So what you're going to do is differentiate this and then compare it with that. So you understand, for this function, dy by dx will be equal to 2ax plus b. If it looks like it, then it is b plus 2ax. They are telling us that it is, they are telling us from this that dy by dx is actually 9 minus half x. So it means that this 2a is minus half and this b is 9. What is that? Huh? If dy by dx equal this, and they tell you that dy by dx is also this, they compare the values. Huh? They tell you the gradient. Gradient is dy by dx. Gradient is dy by dx of a curve. So it means that b here match 9 there, and the plus 2a they match the minus half there. See that? So you can say, therefore, the b is equal to the 9, and 2a is equal to minus half. 2 equals minus half, then the a equals minus a quarter. That's the first thing. So I've already found 2 of the values, the a and the b. Question answer must also find c. C is back in the function. So they tell us that the stationary value is 5. The stationary value occurs with dy by dx equals 0. So we can say that's when that's where you get a stationary value, the dy by dx equals 0. That is the y value at the stationary point. This is the y value at where dy by dx equals 0. So we can say that Let's put it there, sir. So we have space. This space is very small. So let's put it right here, sir. So we know that when dy by dx equals 0, the y value is 5. Because that's a stationary value. Stationary value is a y value. So put in this equals 0. Right? So that's 9 minus half x equals 0. That's x equals 18. So when x equals 18, y equals 5. Plug them in at this to find the c. See that? Plug them in that to find the c. So you can say, therefore, the equation becomes, right? Let's put it here. Sub into y equals ax squared plus bx plus c. Huh? Huh? If this equals 0, then it's equal 18. Half of 18 and 9. I can write 9 equal half x compared by the 2. Right, so we're going to sub into that now to find the c. So we're sub into that. We're going to get the y value is 5. I put them here. So we're going to get 5 equals the a is minus a quarter times the x is 18 at 18 squared plus the b is 9 and the x is 18 plus c. So solve that for the c. Right? Simplify that for the c. So c equals 5 and transpose them over yourself behind the 5. All right. Let me split the screen. Calculator to help myself. Are you guys not helping me? All right. So I'm going to transpose things over behind the 5, right? It's going to come out as a plus and it's going to come out as a minus. So the c is going to be equal to 5 plus this thing right here, so a quarter times 18 squared and then minus 9 times 18. So I'm getting negative 76. You did it yesterday, you get negative 76 for the c. So c equals negative 76. So those are your three values, A, B, and C. Right, so determine the nature of the stationary point. The nature is, you know it's going to be maximum. Because what? Because the A negative. You see that? So it's going to be maximum. And the quadratic with the A negative. So it's going to be maximum. But you see that to show the word. They wanted to do d2y by dx squared. So d2y by dx squared, you differentiating this. Right? Differentiating this thing right here. You're going to get minus a half equals minus half, which is less than 0. Therefore, stationary point is the maximum. All right. 2 marks out with that. Okay, so the stationary point is 18.5 is the maximum point. This 18 and this 5 is the maximum point. Question done. All right, so just wanted us to touch on that. Good. Question, I'm surprised I gave some problems when it was set in the exam as easy as it is. Right? Actually gave some problems. I think the main reason I give a problem because people they realize they just need to compare this to this and equate the values. So that was needed, right? All right. I think a question like this is going to learn specimen paper. The admin specimen paper. All right, down here, son. This one says a drone tracks the movement of an object in motion on the ground. The following movements are recorded. It moves at a constant velocity of 4 meters per second for 5 seconds. 4 meters per second for 5 seconds. So that's a velocity time graph, right? So we could say at 4 meters, or they don't put on any scale on this graph. So we have to scale it up, right? It said its velocity increases uniformly for 3 seconds to 10 meters per second. It moves at that velocity for 7 seconds. It slows uniformly until it comes to rest after 4 seconds. Sketch a graph of the movement. All right, sketch a graph of the movement. So the sum of the time is what? 5, what's wrong with the idea of the time? 5 plus 3 is at the time. Huh? Trying to get an idea of the time to put on the graph. So the length of the time is 5, then 3, then 7, then 4, right? What's that? Huh? 19, huh? 19? 19 seconds. All right. So this one also we can get pick 19 seconds on this. So therefore, we're gonna go 1, 2, 3, 4 on this axis, right? Because it's 19 seconds. So we're gonna go 1, 2, 3, 4. We're gonna go 2, 4, 6, 8, 10, 12. That can't work. Can't work, brother. So we'll go 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Make sure say a lot of the time. So it moves for 5 seconds, then 3 seconds make it 8, 7 seconds, 19 seconds. 19 can open this. Huh? So you can't hold on to it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16 and out. Hello?
Sir, good evening. Are you still at class?
Yes. But I was supposed to leave the compound. No, them said I'm on the one last round. We never said time. Yes, I do the last round and then we'll leave. I don't know exactly the time. Maybe next half an hour to hour. Yeah. Your man said I'm supposed to be at 4. All right. Say yes. All right, cool. Your man, I'm afraid you feel discipline inside there. From to teach. I'm from for discipline. Anyway, let's go. And the speed now went up to what? What's the maximum? 10? Was 10? Can we go up to 10? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. All right. Let's put in the values now. All right. So first it was going at a constant speed of 4 meters per second for 5 seconds. So 5 seconds is right in between here. So, all right. 4 meters per second for 5 seconds. That's right here. The first part of the journey right here. All right. Right to this halfway mark here, so. All right. Then it increases speed for 3 seconds to 10 meters per second. So it reach 8 seconds now, right? 3 more seconds is 8 seconds. So after 8 seconds, it reach 10. So it's 10 all the way plus. So 3 more seconds take you up to 8 seconds. And with a speed of 10. So we're talking about right up here, right up at this point. All right. So we're gonna come from this point. Gonna come from this point straight up to that point right here. All right. What next? Then for 7 seconds, it move at that velocity. It stays at that velocity for 7 seconds. What we reach? 8. 7 and 8 how much? 15. So about the 15 seconds now, which is right in between here. So right in between here. So it held that speed for. So coming right to here, so now, bam. Right. And after that, it decreases speed for 4 more seconds. So 4 more seconds after this is out to what? How much you say we reach? What? So we reach 15? We're at 15 right here, so 15 how much? 4 at 19, right? So 19 is right in between here, so. So it's coming to rest right here, so at 19 seconds. So we need to just come to rest right here, so at 19 seconds. That's sharing. Bam. And that is your velocity time graph. But I said that. Nice and easy. All right, so let's put in this one. This mark was 5 seconds. So in case we need it. Right here, so it was 8. Then right over here, so it was 15. So all those critical junctures that it did. All right. That's a velocity time graph. What do I want us to get from the graph? It says calculate the distance traveled by the object in the second part of the journey. The second part of the journey is right here, so. Huh? Or the bubble paper? No, no. You mean the printed question papers? No, no, right. Right. So the distance, the distance traveled in the second segment. This is the second stage, right? Is the area under the graph. So I want the area down to here, so. I want the area down to here. The area of this little section is what? So the distance traveled is the area shaded there, so don't it? Which takes the shape of a trapezium with these two parallel sides. And this is the distance between the parallel sides. Everybody can say that? What are the dimensions of the parallel side on the sides? So this side is 10, side is 4, and under here, so it's 3. Distance between them. See that? Half AB sine C, where half the sum of the parallel sides, not half the sum of the parallel sides, than the distance between them. These are the parallel sides. This is the distance between them. Good? So the distance traveled is the area shaded. So this distance that I want equals the area shaded on the graph, which is a trapezium. So it's half the sum of the parallel sides, 4 plus 10. Then the distance between the parallel sides is 3. What is that? It's half of 14 is 7, 73 is 21. 21 meters is the distance traveled in the second stage, area under the graph. Huh? No. Distance is in meters. We calculated an area, the distance is in meters. Why is the distance in meters? Because remember that this time is in seconds and this speed is in meters per second. Meters per second times second is seconds cancel. Leave it with meters as a unit of measure. Don't put a meter square on it. All right. All right. What else I want us to do? It's to determine the object's acceleration in the final part of the journey. So because the axis for acceleration, we have to give negative on it. Down here, so the green of this side. If I ask for the retardation and the deceleration, you would not put the negative on it. Because deceleration or retardation is already known to mean reducing speed. But because the ask for acceleration, this is actually a negative acceleration because the speed is actually falling. Right? So put the negative on it this time. Other time you don't put the negative on it. Because when they say find the deceleration, you find the gradient without the sign. So I normally say to the student, deceleration is falling gradient. Acceleration is rising gradient. So acceleration is rise over run, deceleration is fall over run. And a velocity graph. All right? But this time you have to put a negative on it. So acceleration equals gradient. And the gradient is rise over run. And this time the rise is negative 10. See there? Come down 10 and you're on 9. You see that? See that? come down 10, and you run, no, no, you run 4. From 15 to 19 is 4. See that? But you can say that, right? So you rise negative 10 over run 4 in the last second. And you put that in meters per second squared. 10 over 4 is what? 2.5? Negative 2.5. That is it. All right. So let me go to your question. Oh, I want to do this one as well. No, this is something similar to what we did earlier. That's similar to what we did earlier. But let me go to, I think it's 2015. Here's a question that he wants me to do on 2015. 2015. Let me get out of the notes. Let me get out the notes. All right, 2015. Oh, I can't write on this. That was space to write on this. So you want to discuss them about Dominic? Which part of discuss here? Send me the stuff down today. Huh? I believe I tell this the same one. So me get it from. You don't know where you send me. I said, don't need this one done then. Huh? You don't see it? Say send me. So why you send it to me? Huh? It's the third part you want. So you're all right to the first part then. All right. I'm sure you're all right to the first part. Cool. So you want the probability 3. Let's see if we can do it right here. So I want that space, but let's see. All right, so this one says, research in a town shows that if it rains on any day, then the probability that it will rain the following day is 25% or 0.25. Good or a quarter, your choice. Remember, a probability can express as a fraction, as a decimal, or it can be expressed as a percentage as well. It says, if it does not rain, then the probability that it will rain on the following day is less, 12% or 0.12. So let's put it this way. The probability that it will rain is 0.25, so the probability it will not rain is 0.75. That's after a raining day. After a non-raining day, the probability that it will rain is 0.12, so the probability of not raining is 0.88, because the total probability is 1, because 12% is 0.12. So 0.88 is the probability of not raining. So if it don't rain, the probability of not raining again is 0.88. All right. So starting on a Monday, and given that it rained on a Monday, so you know say it rain on a Monday. So if it rain on a Monday, the probability of raining on a Tuesday becomes 25%, don't it? And the probability of not raining on a Tuesday becomes what? 75%. Good? That's first branch. It says draw a probability diagram to illustrate information and show the probability on all branches. It said determine probability that it will rain on a Wednesday. Okay, so we're gonna do this up to Wednesday. All right, we have to do this up to Wednesday. So if whenever we read the last part, we would know that we need to do it up to Wednesday. I was just wondering how far we do it from. I can do probability, right? So this we're doing it up to Wednesday. All right, so ready now. So we're starting on a Monday. So well, we know say it rain on a Monday. So let's do that. So we start on a Monday. Let's set it up like this. Monday. I know that it rained on a Monday. So we know for sure that it rained on a Monday. So after it rained on a Monday, you know say it rain. It's either the Tuesday now. It's either it's gonna rain or it's not gonna rain on the Tuesday. So the probability of it raining on the Tuesday becomes 0.25 Because it rain on the Monday. So because it rain on the Monday, we know so after it rain, the chance of it raining again is 0.25. That's true. All right, let me put it this way. Probability of rain. Let's put that. Let me put it this way. So this is rain and not rain. Now let's put this way. Rain and not rain. Let me not just put so rain is 0.25 on the Tuesday. But not rain, going to put R complement. Boy, come off of your phone, your mother said 0.75. Your mother know what she tell it when she said what she said. You know what she tell me what she said. Like you want phone addict, like the rest of us. Huh? Yeah, phone addict like me. All right? All right? That's the first part. That's on the Tuesday, right? So you come to Wednesday now, guys. You come to Wednesday now. We reach Wednesday now, guys. That's Tuesday. Then we're gonna come over to Wednesday now. Over to Wednesday. Wednesday over here. So when you reach Tuesday, up here, so you're seeing that it rain. So remember, if it rained, maybe we need to put these further up. Put these further up. Up here, out of the way. So up here now, it's like it rained on the Tuesday, right? So if it rained on the Tuesday, then the chance of it raining again is 0.25 and not raining is 0.75, right? So up here now, on the Wednesday, chance of raining on the Wednesday now is R is 0.25 again. You know what I'm saying? If it rain for one day, then so up here when it rain. So if it rain so, then it will rain up here so 0.25 and don't rain down so 0.75. That's that? Remember, you know, when the Monday done, you know, we are saying either it rain or don't rain. So if you're on the rain channel, after the rain, it's going to rain again 0.25. See that? Good. Right. This is on the rain channel. Like it rainfall. So if it rain up here, so that's what 0.25 means it rain, you know. So for it to rain again is 0.25 again. 0.25. And not rain, R prime is going to be 0.75. See that? And then no, then I say if it don't rain, then I say if it don't rain on the Tuesday, right? If it don't rain on the Tuesday, don't I so? Then it can either rain again or don't rain again after that. So watch this now. After it don't rain, the chance of it raining is 0.12. So this has rained down here so now at 0.12 and not raining down here so becomes 0.88, don't it? R prime means not rain. Not raining becomes 0.8. I'm gonna get 0.88. I'm gonna get 0.1. One from one. See that? I say about these channels now. So you reach Wednesday now, right? You reach Wednesday. So you can answer the questions now. So it's a Wednesday. Okay, I see what is happening here. So what is now? Probability of raining and raining, you multiply them. See that? So this is rain on a Wednesday. So rain and rain. This is when you rain and then rain again. Equals, you multiply them 2 here. How much you get? 0.25 times 0.25. That one I know a rain and then don't rain. So 0.625. All right, yeah. 0.0625. Over the small pieces. And then you say no, rain and don't rain. Rain on the Tuesday and then don't rain on the Wednesday. How much is that? 0.1875. Then you say no, don't rain and then rain. Don't rain on the Tuesday and then rain on the Wednesday. How much is that? Don't rain and then rain. What did you report to? How much? 0.09. Everything is at 0.0 after that. You have multiplied 0.75 by 0.12. That's what you get? Sure. All right, and don't answer no. Don't rain and don't rain. Don't rain and don't rain. How much is that? What's that work out to? Don't rain and don't rain. Much? 0.66? 66. So those are probabilities. So watch this now. The probability of raining on a Wednesday is either the 1 year or the 1 year. So you add them. See that? Probability of raining on a Wednesday is either rain to 2 days them and then rain on the Wednesday, or it don't rain on the Tuesday and then rain on the Wednesday. 0.0. Huh? Right. So this is what you understand the probability tree, you know, boss? And then in the probability, ask what's the probability of not raining on the Wednesday? Is either this or this? See that? Let me ask that question. Add them. Because it's or. Is either this possibility or this possibility for raining on a Wednesday? And for not raining on a Wednesday, is either this possibility or this possibility for not raining on a Wednesday? Let me ask that question. Watch this now. Given that, it's a no. Given that it rained on a Wednesday, given that it rained on a Wednesday, what is the probability that it did not rain on the Tuesday? Given that it rained on a Wednesday, what's the probability that it also rained on the Tuesday? Given that it rained on a Wednesday, what's the probability that it also rained on the Tuesday? So watch it now. So what you have basically done, listen to the question now. Given that it rained on a Wednesday, it means that you know we're working with only this and this. You reduce your sample space to that. What I know? Let me see. I don't know the final answer, but it's the method I focus on. Given that it rain on a Wednesday, so you have reduced the sample space to these two. What's the probability that it also rain on the Tuesday? Out of them two, though, which one of them also involve raining on a Tuesday? This one. So the answer then is this out of the total of them two. Then. You understand? Just like it. Given that it rain on a Wednesday, so you have reduced the sample space to just these two alone. You don't care about the rest of them. You are saying you know say it rain on a Tuesday. What is the probability that it also rain on the Tuesday? So the one where it rain on the Tuesday out of the total possibility of raining on a Wednesday is this one. So become that one out of them two here together. You understand? They have reduced the probability. Have reduced the probability. Right. See that? That is it. No, that's what them kind of question I ask them sometimes. So I reduce the sample space to that. All right, so that is the probability true. Let me see what them say. The probability that it will rain on a Wednesday. So it's this plus this. You add them two. I see that? Add those two. So this answer becomes these two. So it becomes 0.0625 plus 0.09. So it's that or that, right? Or means you add. Or means you're gonna add the probabilities. Right? That is it. All right, guys. Which other question I want to look at? Huh? During the break, no, I tell me no want to do that. But they say, tell me if I'm man, I'm gonna half an hour do it. I say, look through and tell me which question. 2022. All right, let's see. 2022. Solve on this one already. This one is already solved on the screen, or the one of the chicken one. Chicken and chips. We did it the other day. But one different question. All right. I can't find a clean copy. No, change this. You can't find another copy. All right, this one. All right. So this one says, at that school canteen, 80% of the students, so these are the students. So the students add up to 100%, right? So they are working percentage, and everything must add up to 100%, right? So I'm gonna put 100 right here. So working in percentages. You could work in 0.8 and all them something if you want, but we cannot work in the hundreds. Whatever number we put in there represent out of 100%, right? So put in 100 for the 100%. All right. So 80% of the students purchase chips. That's right here. So I'm gonna put 80 upon this. So this and this add up to 80. Right? 55 purchase chips. And 55% purchase chicken. So this must add up to 55. So this and this must add up to 55. Cool? It says, of the students who purchase chicken, or of this 55%, right? Careful knowing. Of the students who purchase chicken, that means of this 55, 11% of the 55 do not purchase chips. 11% of them do not purchase chips. 11% of them, the inner, so 11% of 55 don't purchase chips. All right, understand that? So question is, what is 11% of 55 who do not purchase chips? This is 11% of 55, right? So if we read the question, you never say 11% don't purchase, 11% of, you say of the ones who purchase chicken, means that of the cake, 11% of them. So this is 11% of 55. So 11% times 55, using 55 as a value in the table. Like you have 100 people and you have 55 of them. 11% of 55 is how much? How much is that? How much again? 11 over 100 times 55, that's a long my yard. Fees. Huh? Yeah, for the ticket. So, the money again. Huh? Once again? 6.05. 6. Remember, say I don't know the number of people, you know. I could have 1,000 people, you know. Or 10,000 people, you know. You're just working in percentages, it doesn't really matter. So it's 6.05. So inside you're suddenly at 6.05. So the total of 55, now by yourself is how much? 55 minus 6.05. All you want, you can work out 89% of this figure. Huh? 48.95. 48.95. Then no, if everything is at 80 and it's a 48.95, how much is in there, sir? Talk for me. 80 minus 48.9. 31.95. 0 how much? 5. Then everything must add up to 100. How much you gone so far with them 3? How much them add up to? And the difference of a come out is to make the 100%. Add up these to me. So much you gone so far. Suppose I subtract that from 100 because the total must be 100%. How much? 13.95. But understand those, how we get all of those figures. So you can't leave out this, you know. You have to account for the full 100%. So we have accounted for the full 100%, right? I was satisfied. I'm saying 55 the chicken is out of the 55. 80 the chips, so it's add up to the 80. And then everybody add up to 100%. Everybody add up to 100%. All right? So I'm put these in a red. But these are not actual values in the Venn diagram. It's just what the total is supposed to be. Put them in red. These figures. They're not actual values in the Venn diagram. Just showing what the total. But those in purple are my actual values. All right. It says now, determine probability that a student chosen at random purchase only chicken or chips. Chicken or chips, meaning you're gonna add them. So you want chicken. Let me see what it says. Chicken, only chicken. So this is chicken only. This is chips only. So you have to add them. Huh? You say or say chicken only or chips only. So this is people who purchase chips only as person who purchase chicken only. So you add them. See that? So it becomes 31.05 plus 6.05. What is your work out to? 37.1%. 37.1%. Most everything is in percentage. These values are in percentages. All right, that is it. Cool. So you want chicken, chips only or chicken only. One of those two you want. That's the people. These are the people who purchase both chicken and chips. Let's continue. It's done. That's it. Done. The key with that part of the question is say of the persons who purchase chicken. A lot of people got this wrong because they put 11 in a sum. Right, but the question says of the persons who purchase chicken. So you want 11% of the 55. It's done. Don't yes or no. This says probability of occurrence A and B are given as those. Now, there's a probability formula that you must know. They're almost specific every time, which is this. It's also a set formula, connected back to a set formula, which is this. Probability of event A plus probability of event B is equal to probability of A intersect B plus the probability of A union B. So any three of them that you know, you can find the fourth one. Some of them two you must equal some of them two. For any two finite set. All right. So in this example, they give us a probability of A and a probability of B. There's a question one here where they get the probability of, and then get probability of B complement. And it mess up people because them see it as B. I think I last year that. Yeah, we can look at it. All right, so them want this now. So this becomes them two here minus a one. You see that? This becomes them two the minus. So this becomes equal to probability of A plus probability of B minus the probability of the union. See that? This plus this equal that plus that. And you want that one here. Now them two are minus any one of them there. See this. Because the Christopher face look like him see ghost. See that? Good. So you're adding them two here, which is a quarter plus 3/5 minus 7/10. What that all for me at the moment? What that work out to? How much? Sure, 20? Sure? Speak properly in a youth. Sure, 20. Channel. School challenge quiz. All right. Probability of A given that B has occurred. What is equal to? This is equal to probability of A intersect B equal to probability of A intersect B over the probability of B. That's what that is. Now what this represent? This again represent where we reduce sample space. So it's like, I'm just telling you one more time what it means in case you get a situation you want to figure it out. So if you have a Venn diagram, right? Two sets A and B. Right? That's the whole thing. But them say no, probability of A given that B has occurred. It's like you have reduced that sample space to B alone. So B has occurred. You have reduced sample space to B. And you want to know how much of A is in the B. You want to know right in the front. You want to know how much of A is in the B. That's what this means. Understand? It's the same thing I'm asking now. Given that it rain on a Wednesday, what's the chance that it also rain on the Tuesday? So how much of it rain on a Tuesday in the probability of rain on a Wednesday? That's what it means. That's what this means, right? That's what that conditional probability means. How much of A is in B? That's what it's asking. That's what this means. Right? So this inside here represents the probability of A given that B has occurred. That's what that's how it becomes the probability of the intersection over the probability of B. See that? So just I'm going to divide them and see what we get. So the intersection is 3/20, right? And the probability of B was 3/5. What's your quarter? Huh? A quarter, right? It's probability of A given that B has occurred. Now watch this now. If you notice now, I'm going to ask you down. See the relationship of the two. See if they are independent. Now what can make them independent? Watch this now. The probability of A given that B has occurred is also equal to the probability of A, same way. This is a quarter. It means that the probability of A happening don't depend on B at all. See that? If you look right here, so you know, it's the probability of A as well. So we have, look, we have probability of A given that B has occurred is equal to the probability of A, which is a quarter. When this happens, it means that you have independent events. Because the probability of A given that B has occurred is still equal to the probability of A. It means that A don't need to be found. A is independent of B, so they're independent of events. Another way you can know is this. Also, the probability of A intersect B is equal to the probability of A times the probability of B. Then we also have independent events. Let's test it. So probability of A is a quarter, then probability of B, what's probability of B again? 3/5. See, it becomes 3/20, which is the probability of the intersection. See that? So those two things, any one of those two things will make. Now listen, look out for this now, guys. Whether if this happen, you have independent event, or if this happen, you also have independent events. Any one of them two there is a proof for independent events. If the conditional probability equals the probability itself, probability of A given that B has occurred, or the probability of A intersect B equals the probability of A times probability of B, then you have independent events. So we're going to write, therefore, A and B are independent events. What to make two events mutually exclusive? What to make two events mutually exclusive? When are two events mutually exclusive? Huh? Means that there's no time when they occur at the same time. When the intersection equals 0, probability of the intersection equals 0. They are disjoint. They never occur at the same time. They're mutually exclusive. Like the probability of flipping a coin and getting a head versus getting a tail. Either I get a head or a tail. Can't get two of them. Or the probability that a number is even or odd. A number is either even or it is odd. There's no number that is both even and odd. Right. And they have two disjoint sets. So see here, mutually exclusive. Put a note here, so. Mutually exclusive events is when you have sets. We have disjoint sets. I call them disjoint sets. That is. So this is set A and this is set B. So it means that the probability of A intersect B is equal to 0. That's why you have mutual exclusive events. Huh? Huh? You don't understand what I have to say. If you record, if you do a calculation and it's such that intersection is 0, whatever reason, it means that you have mutual exclusive events. Simple. Right? So if you do a question and you get this, you have mutually exclusive events. If you get this or you get this, it means that you have independent events. Right? So the probability of B, given that A has occurred, equal to the probability of B, independent events. And the probability of A intersect B becomes the probability of A times the probability of B, you have independent events. And if the probability of A intersect B is equal to 0, you have mutual exclusive events. So those are some things they will ask you sometimes. All right? So let's make sure we put it on a screen at the so I can see it to remember. All right? Just remind them. All right? Anything else? You want to do a sample space, huh? Stem and leaf? Really? Stem and leaf, brother? Stem and leaf, brother. Eh? Yeah, but I'm not there for the thing there. There. Back up, back up. You can put that leaf on the top. Stem and leaf. All right, I do that one. All right, the stem and leaf there. So, you basically setting up a, I'm just do it. So I put a stem side and a leaf side. I put a line down here like this. So in these numbers, you're gonna put the tens values over here and the ones values over here. So the tens values are not repeated. So you're gonna put all the threes, them 3 values here, or the 30s on one line there, 30s. So you put 3, you have 30, so you put a 0, you have to put a 30, 5, 9. Come on, you know it already, man. Not about that. You're going into the 40s. So you have 42, 45, 45. You're going to the 50s. You have 52, 59. You're going to the 60s. You have 61, 61, 65, 69. You're going to the 70s, so this line up for longer. 70s. You have 70, 71, 75, 77, 79. They're going into the 80s. You have 81, 83, 83, 85, 87, 89. They're going to the 90s. Extend the tone again. 90s. You have 90, 90, 95, and you have 98. So that's your stem and leaf diagram. You're done until you draw a key. You have to draw a key. So you're going to put the key down here and see what it is and see what the line between the numbers means. So for example, you can get them 6/1 means 61. Give them that. You have to give them the key. All right? And if you have one, we go up to, you have one, we go up to 100. You put the 10 over here, so suppose you have 103, for example. You put 10 over there, so, and 3 there, so. And you have to put 10/3 means 103. You put a second line with double digit there. Yeah. All right. Question says, state one advantage of using a stem and leaf diagram to display the data. Huh? It's organized, the values are more compact, and you don't repeat the stem values. Yeah? You don't repeat the stem values. 3 marks? Huh? Yeah, 4 marks with your stem and leaf diagram. Yeah, but some people still get it wrong. So the values are presented in a compact form. The stem value is not repeated, right? So you can say values presented in a compact format without eating the stem value. All right, so you don't repeat the stem values. All right. It also can give an indication of the skewness of your data in a sense. Like it can also give an indication of the skew. You can say kind of heavy down as well with the number. See it? Like you can say you're heavy in a sense. They can see it with individual variables. Huh? You don't know what's where the median is. Alright? So go see the median and show the values distribute. I remember say that scale. I say the thing is that scale diagram. Right? That scale diagram. So we'll see. This one says now state the range of the values. So the largest value minus the smallest value. So it's oh, look at that 10 tree. It's not part of oh shit. That's not a part of it. So it becomes 98 minus 30, right? 98 minus 30, which is 68. I said the data below shows the following box and whisker plot. Is it for this one? Yes, it is. So they do it for us already. Right? So they do it for us already. Suppose we have to do it yourself. We have to find the median, or you have to find the median. Suppose you have to do it yourself. You have to find the median. How many scores are there? 27 scores, right? So there are 27 scores, like you take out the median. I have 26 steps. You have 13 and 13. I have the median is a 14 value in the middle. So the 14 value is in the middle, right? So for the 14 value, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 71. If it was an even number of values, you have to average two middle ones, right? So the 71 right here. That is your Q2. Then now you have a bottom half up here, so, of the data. I want the middle of that bottom half. That's a 13 value down here. So if you have 13 values in the bottom half, so take out one out of them again. Come on. You have 12 left. So 6 and 6. So the seventh value down here, so now it's Q1, right? The donor saw the seventh, so this is Q2. So donor saw the seventh value. See that? Seventh value. And up here, so the seventh value from this way, from the end. See that? The seventh value from the beginning and that end, the seventh value from the end at that end is the Q3. Everything is symmetrical. So you get the seventh value this way from this end. Seventh value this way. So this is a Q3. So the seventh value 1, 2, 3, 4, 5, 6, 7, that's 52. So this is Q1. It's 52 right here. So it's Q1. The seventh value from the end 1, 2, 3, 4, 5, 6, 7. That's this value right here. That 85 is Q3. This is Q3. So I've done it first already. So see there 85, 52. 52 we get that 51. But I'm mistaken at 51 we get. Oh, 52, yeah. 52. All right. All right. It says now, state two distinct observation about the data as seen in the box and whisker plot. All right, two distinct observation. What we can say about it? Can say negatively skewed, don't it? So it's actually negatively skewed. It's negatively skewed, a side are longer than a side. So negatively skewed or left skewed. What them say, just tell them the median is 71. The lower quartile is that, upper quartile is, I will just tell them that. That's observation we can see from the box and it's a plot. That's what the box and whisker plot show you, show the quartile. That's so you can the interquartile range, which is here to here, so and negative is skewed. Right? So you get a quartile, two observations that we know the quartiles. So the quartiles are 52, 71, and 85. These are the quartiles. Quartiles are Q1 equals 52, Q2 equals 71, Q3 equals 85. You can also say Q2 is the median. Q2 equals 52 is the median. The marks of it 2, may I get them all 10. So you can't say them, I get to them all. I'm going to say this, the distribution is left skewed. Skewed to the left. The negative is skewed. The data is negatively skewed. Huh? I'm going to put 72, my mistake. 71. Thanks for that. 71. Data is negatively skewed. All right, left skewed. Yeah. The left side longer. So the box on the left side longer, the scup on the left side. So it's positively skewed, the right side will go left. See? See that? So it means that the data on the left side are more widely spread from each other in part. But that's what I mean. So negative is true. All right. That's 2022. That's good. Which other one I know? I'm going to talk fast. Time is running out. 50% left on the box. What I say? Which one I said? Which one I said? You want to go? You're done? All right. Huh? Online, anybody want anything? Send the video. Anybody want anything online? All right. So the papers are done then. Good. All right. So look here now. Remember, me have solutions for all of them. Something, all of these papers. You look through the paper and see anything you want. You can just send you a solution. If it's even just that, you can just so send me a solution for this. Send me a solution for that. Right? I can send you either the video solution that I might have online somewhere, or I can send you the written solution. All right. So that is it, guys. Like, watch me now. So tomorrow, 6 questions. You need to give each question 25 minutes. Don't spend more than 25 minutes per question. Watch me now. No, seriously. 25 minutes per question. Just listen. Just listen. Just listen. 25 minutes per question. Remember, each question has a number of parts. So, on each part, like on question one, do the parts of question one that you know how to do. Remember, each question one might have 5 parts, but each of the parts are different questions from a different topic. So, do the parts that you know first. Okay. Yeah, do the parts that you know first, because the space is there for you to write. Do the work. So, part one is a polynomial, but part two is a logs, and look on the logs and look where to you. Do the polynomial and skip the logs for the time being. Do the whole paper where you know first. You don't want to come out of the exam and find, say, you could have done number 6. I never reach it. That doesn't make no sense. So you're not supposed to spend more than 25 minutes on any question. Do the parts that you know first, and then you come back. And if you're not fortunate, you might get an easy paper like the pyramid people. I'm going to tell you, pyramid people get that pyramid people get an easy paper. All right, guys. I just said I did what I could. It's up to you now. But you can send me a message if anything, all right? Anything you send me a message. Watch me now. Hey, remember I want to tell you the time. Go through the multiple choice. What I might do is just send the solution them. At least read through them. The multiple choice them. Because the thing about the multiple choice is that it covers a wide range of topics. So something you want to encounter in a paper 2, you might see them on the paper 1 to jog the memory of what to do. And some of the paper 1 questions are like full questions that can also come on paper 2. I tell you. Yeah, me. So I will send them solutions there for the past 4 years. And I'll just look through them. If you can't do them, just read through. All right, that is it. Guys. Good luck. Come on. Yeah, man. Cool. Yeah, man. No problem. Bye, people online. I'm going to end it now. Good luck in the exam tomorrow.